Hello, ladies and gentlemen. My name is Rex. I'm here with my co-host John, and once again we have the scientist himself back with us on a video. This time, Dr. Tom Carr, to do a part 2 review of the real, quote-unquote, real T.rex. So basically, we are going to simply continue knocking down the list of our points as we were doing in the last session. And I think there is a point there that really deserves to be brought up. And I find it very interesting how cheeky the program was, because they never actually addressed this part. What they did was they actually introduced the model of T.rex with quote-unquote lizard lips. But the funny part is they never actually say anything about that, about why he chose to do it this way or not, because I would have thought that this would have been a point of some kind of discussion as well, because they would think, oh yeah, if you have teeth on the outside, it's like Jurassic Park-y basically, right? That's what they usually like to say. But in actual fact, they should be like this, but they never actually brought this up. Now, I will pretty much say that it's safe to say here that many people who view those, especially my haters in particular, I call them haters, but I don't know if they actually hate me or not. But they really like, let's just say my critiques, my critiques. They always think that I am basically in a camp, if you will, with Dr. Tom here, with a few other people who openly criticize and do not support this trend of applying quote-unquote lips to not just dinosaurs, but archosauromorphs in general, because it's been spreading around like wildfire pretty much across the board. It's not just exclusive to any even specific groups of theropods, it's literally everywhere right now. So even some terrestrial crocodilians apparently have been lip serviced as of yet. I've heard seen some models being going around as well. So that's how far it's going. So first one, I would like to say, John, have you noticed this little detail, and what were your thoughts about this one?
I have noticed this little detail, and I actually pulled up some images of the real T.rex model on my computer so I can look at those for reference. I can say, for me personally, based on all the depictions of lipped T.rex that I've seen, it's not the worst, but I've mentioned this in my first collab with you, Arsene, and I'm going to say it here again. I am very much a proponent of Tyrannosaurus Rex lacking lips, if nothing else, because it's got some very big teeth. And when you get very big teeth like that, you either need to have a lot of muscle there in order for them to adequately slip into the lips, or you just don't have them to begin with, because otherwise you risk the lips being split open. And I know that was a bit of a point of contention, but I wholeheartedly do believe that. And in the case of the model here, I'm not seeing anything that would indicate these teeth are going to properly just fit neatly into the lips. They're just going to split them open again. And it's something that if you're going to do it, you have to keep that in mind, because otherwise you're going to have a pretty bloody mouth T.rex or theropod in general, unless you decide to ignore that. But if you want to be like real, if you want to be accurate about it, you would have to have that be a thing. So that's my personal take on the T.rex. It's not the worst from what I've seen, but it falls into the same issues that I've seen throughout.
So yeah, this is basically just for people to see quickly. When John was referencing the model, he was referencing the one that is on the left side on the image, which is basically what the BBC's version actually is. The one on the right-hand side, we will definitely comment on this when we get to talking about the, the edit that has actually been done to this particular piece here by, you can see it's Fred the Dinosaur Man. That's what he is known as, at least. And he's just an artist, basically, mostly 3D artist, but I think he does digital paintings. He decided to do an edit long time ago, and that's what he came up with. Dr. Tom, what are your thoughts about what we have said regarding the quote unquote lipped. I always keep having to insert air quotes because they're not even proper lips anyway, because lips are a mammalian thing anyway. So what are your thoughts on this basically trope in general, and also on the fact of how sneakily BBC have decided to put that on without even actually addressing why they did that specifically, even though this could have actually been a bit of a point to listen to, at least to understand what was behind the reasoning, at least. So what are your thoughts on this?
Yeah, it's interesting that they didn't discuss it. It would have been an interesting point of discussion. Do you know what year the documentary was done?
It was
I don't
2018, I believe, 2018.
Okay, so my work on this question was already out, I suppose, or at least, you know, when the show was being produced and filmed. So it is interesting that they don't draw attention to it and they just take it for granted. And, you know, the main issue is that most soft tissue issues are taken for granted, and there are features like lips that have sort of locked in for no real reason. So when it comes to soft tissue issues, so, you know, does a dinosaur have an eyeball or lips in this case? There is basically a two-step approach to answering soft tissue questions in the science. And the first is to set the null hypothesis, and that is, what should we expect to see given common ancestry? And so, as you know, dinosaurs are nested within Archosauria, and the living dinosaurs are birds. The closest relatives of the non-avian dinosaur bird clade are crocodilians. Outside that are turtles, and then outside that are, you know, tuatars, lizards and snakes, squamata or Lepidosauria. And then outside of that, we have a bunch of tetrapods, amphibians. And so the question is, does the common ancestor of Archosaurs have lips? And if we sample all living Archosaurs, so turtles, crocs, and birds, none of them share lips. Therefore, the ancestral condition would be a lipless ancestor. And that sets the null. It doesn't mean it's true. It just gives us something to test. And it gives us a starting point as scientists. You know, it could be that lips, you know, if they were present in Archosaurs ancestrally, it could be that they were independently lost several times. Oh, by the way, I forgot to mention that the synapsida are outside of the you know, the Lepidosaur Archosaurian clade. So it goes, you know, Archosaurs, Lepidosauria, and synapsida.
Yep,
and,
no problem. So, still, the point applies all the same anyway.
Yeah. So ancestrally, we do see, so in mammals, we do have definitely lips and cheeks. They're a suckling system that's obviously unique to advanced synapsida. We have lip-like structures that are in basal tetrapods and are in squamates and, well, I guess null Lepidosauria. But Archosauria stands out in, you know, lacking lips, whether or not there's a beak in the case of turtles and birds, or just teeth without a beak, which is what we see in crocs. So bottom line, so the second step is to look at the interaction between soft tissues and bones. And the fact is that bone is a morphologically very plastic or labile, easily changeable tissue. It's not a fixed hard structure. It's shaped by the soft tissues that attach to it. And the bones of the face are no exception. And back in 2016, when I took on the question of the integument of the face, and working out what the variety of textures actually meant on Tyrannosaur faces. So there's like a general texture that looks like wrinkled leather. There is a texture that is marked by a little pustule, like little bumps. There's other textures like raised edges with deeply etched neurovascular canals. And so I just took on the task of figuring out what that stuff was. And the first place I went was to the literature. And there's an excellent paper by Hieronymus et al., Tobin Hieronymus, back in 2009. And they took on the issue of bone texture in archosaurs, particularly ceratopsians. But they surveyed a whole bunch of amniotes. And they're able to correlate specific textures with specific types of soft tissues. And for those of us who are anatomists and understand the interaction between soft and hard tissues, that came as no surprise, that there would be a correlation between tissue type and bone texture. That's the sort of thing that enables us to identify, things like insertions of muscles on bones, excavations made by air sacs, that sort of thing. So it's a long list and it's a reliable one. But the one loose thread, to my mind, was what's going on with this wrinkled leather texture that's the dominant texture of Tyrannosaur faces and other theropods. And I initially focused on something else, the foramina and grooves. They're called sulci. So the foramina are openings that through which a neurovasculature nerve, artery, and vein will leave that opening and scour a groove into the external surface of the bone. So I focused on that. And for about a year, I convinced myself that that Tyrannosaur faces were covered in a giant beak. And in fact, I had my illustrator draw a picture of a T.rex or a Daspletosaurus with its head covered in a giant beak. And I was on the phone, after that, I was on the phone with a colleague, and I had a alligator skull in my hand, an ostrich skull in the other. And I was describing to my colleague, how there's evidence for a beak. And then my eye got the texture on the alligator. And in a flash, I knew the beak hypothesis was totally wrong, because the texture of the facial bones of an alligator had that wrinkled leather texture, exactly like a Tyrannosaur or a theropod or many theropods. And I realized that I have to take the evidence together, the foramina and grooves and also the texture. And when you account for all the evidence, there's only one hypothesis left available, and that's the flat scales that we see in crocodilians. It's that type of integument that produces that wrinkled leather texture. And so we couldn't exclude that, because the texture of the face and the form of the foramina and sulci matched crocodilians and didn't match anything else. So we don't have to invoke anything like teeth being too big or too small. We can actually look at the bones directly. And what's interesting about this wrinkled leather texture is that in crocodilians and in Tyrannosaurs, it goes all the way down to the margin of the mouth. And what that means is that that's where the scales go in crocs, we know that. And so it had to be the same in Tyrannosaurs. And so, consistent with all other archosaurs, the evidence shows that, they had these flat scales, and also they went to the margins of the mouth just like a crocodilian, which means that, like other archosaurs, they lost those flat things that we see in Lepidosaurs, whatever those flat things are. I guess we can call them lips informally. Definitely different from what we see in mammals. But we can use the bones themselves. Notice one last thing. I know I'm talking too much about this, but one last thing is—
No problem, by the way, so perfectly fine. Sorry. It's all good.
Okay. And we see this texture on the upper jaws and lower jaws as well. And so, Tyrannosaurs replace their teeth every 1.5 to 2 years. They can take a beating, but they're okay. And that rate of replacement has to be sufficient to offset, the rough and tumble lives that they had. So there wasn't anything intrinsically problematic for teeth having a lipless mouth. We see that in crocodilians. Crocs don't spend all their time in the water. They're often on dry land. Crocs also break their teeth on their prey, but they lose and replace those teeth eventually. So, I think that was a real missed opportunity for the documentary not to talk about lips.
It's very interesting when you brought up, few things actually. First of all, I found it very nice I would say I was almost tempted to just take notes about what is the very organized way to approach a two-step test. So first of all, to check whether or not it tests against the null hypothesis, knowing, by the way, fully aware that this could still be wrong, but that's why we call it hypothesis, I guess. And the other one that stood out to me was when you mentioned, at the last part, when you mentioned crocodilians spending a lot of time on land as well. Thus, obviously, we're challenging here the whole argument that, if they are not, if they are terrestrial, they would need to stay hydrated somehow, or else their teeth are going to dry out and something bad's going to happen to them. I have something else that I wanted to add to this argument, and with the fact that you said that they spend a lot of time on land also is consistent with the process that they go into, which is called aestivation, I believe, which is when they literally spend months, literally months on land without actually any, attempts to go back into the water. It's almost like, not to sound very, I don't know, like I'm trying to oversimplify it, but I think it's very akin to a form of hibernation, perhaps, when they just simply spend a certain fixed amount of time, basically just, I would say napping. I don't even know what really they're doing at the time, but they do stay out of water though.
Yeah, I don't know much about what crocodilians do. I know that American alligators do. I think they do hibernate, that they will burrow. It's kind of interesting that they'll burrow and they'll hibernate. I don't know the time scale, whether it's weeks or months, but certainly they probably aren't, soaking their teeth while they're doing that.
Well, that is the main point, though, isn't it? They're not actually constantly engaging into soaking their teeth, as you correctly pointed out. And then we have toothed pterosaurs, which is another interesting one, which is pretty much evidence that they have their teeth. And there's no way you're going to put lips on that damn thing, by the way. Just look at some toothed pterosaurs and you will know why. It's just practically impossible.
Yeah, there's an interesting side issue here. And so with the initial and wrong beak hypothesis, that combined presence of beak and teeth. So my idea was that the beak would cover the whole face and the teeth would be emerging, immediately medial to the beak. And I've since spoken with a colleague who has looked into this broader issue of beaks and teeth and concluded that you can't have both. Like, you can't have a beak alongside teeth. Now, but you can have a region of beak where there's no teeth, as we see in nearly all Ornithischia, but we don't have teeth emerging from beaks. It seems to be some intrinsic barrier. I don't know much about what that barrier might be, but pterosaurs are an interesting point. So if archosaurs are ancestrally, lipless, it raises a question of what is the integument on pterosaur heads. Is it scales? Is it like something like we see in theropods, or could there be a beak plus teeth? And I'm really ignorant about pterosaurian osteology, but it raises the question. I wonder about them.
I am curious as well, and the other thing that I found curious specifically was that although there was at least one paper that I've seen, I can't name it right now, but I promise if somebody wants in the comments, I will dig it up, or at least I will find an article of some kind of description where it is referenced directly. I can at least say that much. There is definitely a way to find it and trace it. I don't have it on me right now because I actually because I actually just remembered about its existence right now. And I didn't even plan on bringing up pterosaurs in this discussion because I just remember that there are two pterosaurs out there and they show evidence of animal. So this is the key part as well, that they do show that they had animal. The problem is it's not as well preserved, perhaps, but it is preserved nevertheless. So the fact that it's a poor preservation doesn't mean we already have evidence that it does exist. It just means that it's not as well preserved as in some other taxa that we see, perhaps.
Well, I think that's an excellent point, that if pterosaurs were lipless as well, then Rhamphorhynchus is faced with the same problem as T.rex. With regard to this drying out notion, which, as far as I know, doesn't have really any support in terms of being an issue that requires that we invoke soft tissue covering over teeth. So I think Rhamphorhynchus presents a bigger problem for having lips than T.rex, because those teeth that go way past the mandibles.
Do you want to hear an even weirder one that is actually alive today, by the way, and that is mammalian, by the way. It's, I think, a musk deer, John. Is that what it is? Musk deer, or they are also known as vampire deer.
Mhm.
Yes. You're thinking about musk deer there. Yes.
Mm-hmm.
So basically, yes, those are teeth. As far as I know, they're not like elephant tusks, to my knowledge. And they are sticking all the way down. It's a very cute looking face with like big teeth out of there, basically at the front, which is quite funny. But
they're charming.
Yeah, they're very charming, but they do exist. They don't have lips covering that area. And they're mammals, by the way, the animals that I believe generally, if they do replace their teeth, which we do as humans, at least we do, the Homo sapiens, I don't know about other mammals. But if they do, as far as I'm aware of mammals, generally, if they replace their teeth, they do it once. I believe there's only one time they change their milk teeth, as they are called frequently in common language, and then they have their proper teeth for life at that point. So if you lose your proper tooth, that's it, it's gone. So doesn't it not need lips to protect it? So I'm thinking.
I think that the important point here is that we don't need to go any further than the osteology of animal concern to answer soft tissue questions. And so we don't have to pull in these extra arguments. We can just stick with the bones. And usually there's plenty of data there to, test the hypothesis one way or another. And I think that this whole question of lips in theropods is an excellent case of that point, is we don't need to invoke, enamel drying. We don't need to invoke, problems for biting their own faces. We just need to look at the bones and understand what the interactions of soft and hard tissues are. And we can arrive at a pretty defensible position.
And from Carr et al., even though, as far as I remember, it didn't specifically make that sort of point of contention, like it didn't really say highlight it as a bold sort of statement that the Spletosaurus does not have lips. Basically, I do not recall saying something like that specifically, but what I think we can do is to look at the description of where the integument actually is located and the consistency of its location. For example, you as the writer, the primary, in fact, writer of the paper, Carr et al., so it's after you. So obviously you're the primary main author of the paper. Could you verify whether or not the alignment of the integument that you have observed, the traces of it on the Spletosaurus horneri, was consistent, and rather it was not attributed, something that we could potentially exclude, areas of poor preservation, and remove that argument from this equation and actually tell us that this was actually how it was going and there was no way for it to go any further than that, so that we can understand, can it go further but it didn't get preserved, or do we simply not see this consistently in the area, especially on the maxilla or any other place where you have observed it? So what are your thoughts on this part?
Yeah, it's everywhere. You can work between both sides. And also, these textures are seen in all Tyrannosaurids. It's just that the type of horner eye was a really good example. But the basic hypothesis that we published is applicable to all Tyrannosaurids, including Bistachioversor. It goes back that far in the tree. And just looking back on it, there's two things I probably would have done differently. So I considered the illustration of the integument to be the hypothesis, and we do describe it in the paper and in the sub-info. But you're right, I didn't explicitly say there's no lips because I thought that was obvious from the diagram, that it's a crocodile-like integument, which means no lips. And I should have made that statement explicitly. But as I said, that was implicit in the diagram. I didn't think it was necessary. And the other thing I would have done differently was include photographs of the textures in Crocs and in Tyrannosaurus to show exactly what we were talking about. And I think in general, people to this day, don't really understand what texture we're actually discussing. So I would have done that a bit differently as well. As I mentioned while we were off camera, I'm working on the Jane monograph, which is a description of the subadult Rex. And I will include illustrations, showing integument types, so comparative illustrations, so we can just clear that up. But those are two things I would have done a bit differently. And also to come back to the documentary, I think, the variety of textures on the head of T-Rex would have been a really nice focus for them to take on, because it isn't croc skin. There's armor-like skin on the front and top of the snout, at the chin, on the jugal horn of all places, which is weird. And the only place where we see keratin is on the postorbital, where we have a clear elevated edge along the horn and actually going down the postorbital bar. So it's, a missed opportunity. Again, maybe the timing of the publication didn't line up well for them, but, it'd be nice to see, that in a documentary at some time.
I would say I appreciate the fact that the last part, that you are being very charitable, that they just happened to have missed the opportunity rather than willfully ignored it. I'm really happy that you are actually somewhat bringing a bit more variety into this in that sense, because despite being generally very good critic of depictions, you actually show a very different side to yourself in that regard, to your character, when you are approaching these things. See, I am known to be like a critic, a cynic, just all the way basically dunking, and I think people at this point, just like whenever they hear, not that I am very famous, but in the places where people do know me, they immediately think, oh my god, it's this demon, like they think of me as some kind of demon who basically just does it for the sake of doing it. Well, maybe it's because of how I do it, they fail to see what is my reasoning behind it, rather than the fact that I am doing it, because, I'm not the only one doing it. There are other people doing it, but there may be different ways of doing it, and there may be different reasoning behind how I arrived to these conclusions. So, but yes, I am very curious to see what you would go to in that regard. Hopefully the monograph will actually be, just to double check as well, monograph will be part of the also officially published scientific literature, right? So it's actually it's actually going to go through all these stages, peer review as well, if I may confirm.
Yeah, it will be peer reviewed, and actually we do take on some soft tissue issues. So there's been some great work done by Casey Holliday and Larry Whitmer on the head musculature of archosaurs and dinosaurs, and so I incorporate that work as well. Diagrams showing what the musculature of Jane's head would have looked like based on that work. It's their work, not mine, but in science we have to make use of what has done before us. We have to constantly reinvent the wheel. And there's just straightforward stuff that I noticed in illustrations and models of dinosaurs. I can't remember what the Chris Packham version looks like, but there's basic stuff like the corner of the mouth. And the corner of the mouth is actually defined by an anatomical structure. And usually people put the corner of the mouth ahead of where it should be. And that doesn't look so bad. The real T.rex one, which I actually like, the revised version on the right there is nice. It's a nice one, but I do think that the corner of the mouth is a bit further ahead of where it should be. But it's just, the point here is that you really have to know the anatomy really well to avoid making some very straightforward mistakes. But it's a learning process. I'll stop there.
Yeah, no worries, no worries. I'm just I just wanted to say that, I mean, I can even myself verify how many times I wrote you tons of PMs, over Facebook when I was asking, what do you think of this feature? What do you think of that feature? Does that ring a bell? Does that land well? What, just these kind of very serious, silly kind of very straightforward questions. But when I started really sitting down and mulling it over and actually tried it on for size, I realized that all of a sudden I'm actually stuck. And I'm not able to properly verify it because I may be seeing it in front of me, but I'm not able to really understand if this is what I should be seeing, or should I be looking elsewhere? Because a lot of times I don't have the qualifications, if you will, or the experience to actually know what I'm looking for. So you would probably remember that I worked a few times when I would definitely throw in a couple messages with either pictures accompanying them, trying to verify whether or not I'm on the right track.
Yeah. Well, the beauty of it is that soft tissues have attracted a great deal of good scientific attention. So as I mentioned, there's the Holiday and Whitmer work. John Hutchinson has done some really good work deducing the hind limb and hip anatomy of theropods. And so the stuff is out there to draw upon. And also, my friends who are artists, paleo artists, I tell them, hell, you can just go down to the grocery store and buy a dinosaur and tear its skin off and, get and learn the muscles. You don't have to learn the names or anything, at least get familiar with what the muscles are like, how they're arranged on the legs. So of course, I'm talking about chickens. So we have, models of real dinosaurs that we can use to get used to anatomy and thinking, in those terms instead of guessing.
In that case, maybe let your friends know just in case before they plan something like this. So maybe I can join the party, and after that I will cook them spicy chicken curry because I'm a chef as well of the YouTube, if you will. So I can definitely make a nice one for you.
Sounds great.
All right. Well, are we happy with this particular point? Tom is happy. What about you, John? Are you happy with this, or did you want to address the lips issue? A few more things. Maybe Dr. Carr can add something if you say something interesting.
I think this mostly covers it. I agree on the whole. Obviously, there's plenty of evidence you can find in the bones to indicate whether or not, or through the scientific process of figuring out whether or not theropods did have lips. My sort of layman argument there with the whole lip splitting was sort of more of a I guess intuition kind of thing, because when I try to talk about this, I sometimes I don't always have like all the technical aspects down pat. So what I try to do is look at things through a bit more of an intuitive sort of thing. For example, when I brought up in my first collab with Arsene, that one of the things that I noticed when you try and lip large theropods, you end up shrinking the teeth. A lot of people, well, I shouldn't say a lot of people, but a few people did not take kindly to that. And and I would argue that the reason why I bring up the shrinking teeth idea is that, again, with Tyrannosaurus Rex, and I would go further and say animals like Torvosaurus or animals like Spinosaurus, and well, Spinosaurus in general. These are very big
Ceratosaurus as
teeth.
well.
Oh yeah, Ceratosaurus especially. These are very big teeth, and you have to accommodate them. And so, from a general perspective, not even necessarily going into the nitty gritty details, not to bemoan that by any means, but just looking at that from a strictly general perspective, it's very hard to reconcile lips without some sacrifices in, I guess you could say, accuracy. And the big thing for me was making the teeth just small enough to allow for lips that even make sense, let alone even look practical. So, but otherwise, that's pretty much all I have to say on the lips argument. I pretty much said my piece in the first collab, and I'm glad that I could hear Dr. Carr's side of things with the more scientific and technical side of things. So, when I look back on this, I can maybe apply it to when I talk again with my friends and family about this. So, but I just thought I'd get that out of the way now.
Yeah, just one last thing. Yeah, I think there is, the systematic approach, and then along the way, as you mentioned, like trying to deal with doing a reconstruction that anatomically makes sense, you might uncover problems that that no one's considered before. I think that's valid. I know from, I can't recall whether it was Jurassic Park or which production, but it turned out that the animators, the digital animators, found that their models for dinosaur motion would only make sense if done in some particular way, like say, the sequence, the alternating sequence of arms and legs, for example, that it didn't work or didn't make sense. There's a variety of ways of doing these things, but they could quickly identify things that didn't make sense, and those aspects might have been validated by scientists. This isn't published or anything, it's just observational. But yeah, I think during the process of reconstruction, we're able to uncover problems that, would slip by maybe, the more formal process. And also, one last thing is, I teach a dinosaur evolution course, and one of the labs for the students is to do this two-step process of recovering or inferring soft tissues in dinosaurs, using the literature, the anatomical literature on modern animals, and then doing the phylogenetic bracket for dinosaurs and seeing, what a certain muscle would look like, if there's any differences depending on, the animals compared. Like sometimes birds will have muscles that divide into 3 bellies, whereas in crocodilians, it's only 1 belly. Then they have to make a decision of, which way to go with that, if they can. So this is something that you can do yourself. It's as long as you have the literature and a program like Mesquite, which is used for putting together data matrices for cladistic analysis. It's good at visualizing the bracket and this sort of thing.
Sounds good.
Yeah.
It does sound like a very interesting, I would say, even mental exercise as well. Imagine sitting there really just mulling it over, trying to think, so am I going to use this type of muscle or that type of muscle? How do I determine which is more practical? Why do these have this one and why do the other ones have a different one? Maybe that might be another way to try and approach it, provided that you are actually able to find out why.
Yeah, tree thinking is really important. So thinking in terms of relationships. I just had a student present some work on basal synapsids, and someone in the audience asked, did basal synapsids give live birth or lay eggs? And which is a good, legit question. And so if you apply the bracket, say the dinosaur line reptiles, laid eggs. The basal-most modern mammals lay eggs. The classic amniote egg. Therefore, basal synapsids like Edaphosaurus, Ophiachodon, that sort of thing, would have laid eggs as well. And that gives us the null. And that's something you just do in your head, as long as you know the tree. It really narrows down the options really quickly. It's a very helpful tool for scientists and artists alike.
I think a very interesting part about this is that artists, and this is also applicable to documentary creators all the same as well, because artists get heavily involved in creating documentary projects like this, especially some other ones that we get to see in regards to what me and John are generally reviewing on this channel and planning to review on this channel as we go further down as well. And the real T-Rex in this case is no exception, because one of the primary objectives of the host, Chris Packham, it was to try to restore it in its flesh and blood with all the things that come with it. And the aim was to show you what the real T-Rex would have looked like. And we've already seen what it turned out to be. And there are a few other things I wanted to touch on when we go to the next point. So I think we can be pretty happy about, last part, just one last part. And after that, I promise we move on from the so-called lips conversation. That's still taken up quite a lot. It's a big point though, anyway, because it's encompassing of the soft tissue in general. So I think that's why it's probably quite big in its discussion, because it's a complex subject. So that's how it is. But frequently I hear the argument being used to advocate for, especially as John correctly pointed out, the shrinkage of the teeth, is that there is presumably a lot of tooth slippage that occurs, and therefore teeth should not nearly be as big. But then I have people, at least that I know, who work as curators in places like Utah, for example, shout out to Jeffrey, and other people as well, who have personally looked at and lifted these different skulls, and they've picked up the teeth, they've seen the sockets, and everything, and they can pretty much say that it may only be perhaps true to a certain degree, but it doesn't necessarily apply to it to the point where you can actually get away with such liberty of completely just shrinking them beyond crazy, in that sense. So what are your thoughts about this argument of the tooth slippage, and what can you say? Do we just simply experience this as a typical phenomenon, or are we actually seeing animals with legitimately big teeth, which kind of puts this point in a kind of a jeopardy, if you will?
Yeah, I think it's an interesting question. I do think that what we see is what we get. There are obvious instances where teeth have slipped far out of their sockets and the root is maximally exposed, that sort of thing. But I think it's a legitimate question to ask. I think it's a good project for a student to take on, and that is, say, comparing maximal tooth eruption in a modern model like crocodilians, and to get a real sense of what the rules are, is how far out can a tooth go before it's, it drops out, is functionally, wiggling around too much and doesn't do anything. So I think that's a legitimate scientific question. And then, so if we have a baseline based on crocs, then we can look at, things like theropods and other archosaurs and get a sense of whether or not individual teeth are, beyond a certain anatomical limit. I think it's a legit scientific question. I do not think it has been answered. So I think would be a neat project for someone to do.
And this is what I think the attention gets drawn away from. It's rather than actually trying to look at it as independently a very good idea for a project in science to further understand how they would look and to get a better idea of what they would look like in practice, and how would that potentially affect how they applied, them as tools for whatever it is they needed to do, which is basically get food and eat. And it gets overshadowed by an attempt to use it as some kind of backdoor argument to justify a certain model, which as we already know, even the basic technical approach, like a two-step hypothesis, it doesn't check out on that. It doesn't check out if you go further, and it pretty much just falls apart all the way through. And yet this, something like this, fascinating, and this is a bit frustrating that it gets used as a backdoor argument for these things, but it doesn't actually seem to be occurring to the same very people that this in itself is a very interesting topic to actually look into, which you know, many people have not actually looked into it that well yet, at least not that we know of it, you know, to my knowledge anyway. So it would have been very interesting to see what, you know, the restoration. It also very interesting how, you know, when you see in crocodilians, you have some of them that have teeth quite big. Otherwise, other individuals of the same species, sometimes they have teeth that are only like a few only sticking out, and they almost disappear, both in the older and younger, but mostly in the older specimens. But sometimes you have older specimens with big teeth, and other times you have specimens which have almost no visible teeth, just a few bumps there, and you're even wondering how they manage to actually do anything with you know, with these things. But I mean, would be pretty fascinating to see if we can find some kind of parallel happening in theropods, whichever group it is. There may be some better candidates for this as well, like Abelisaurs, which generally have very small teeth as it is. There may be some other ones. So I thought, why don't we look into that? But what do I know? I'm a pleb. I don't know anything, right?
Good question. But like I said, you know, with the fossil record, my default is, you know, what we're seeing almost certainly maps onto reality, unless it's, you know, dead obvious that, you know, teeth have slid out and are, you know, you only have the tips of the roots still in the sockets. Well, then, okay, there's that tooth has slipped out, and there are examples of that. But I think with many articulated skulls with the teeth still implanted, you know, that probably reflects nature somewhat accurately.
Perfect. Now, I wanted to ask John specifically here to bring up a point about how the program was using birds and how they drew this ancestral line of how dinosaurs are related to them, which I know was a big problem for you, and they used that as one of the arguments of how they should be looking at Tyrannosaurus Rex as well. Now, I don't necessarily have an issue with them using birds per se, but it's very interesting of the rhetoric. You know, the rhetoric itself is sometimes what plays an important part. It's almost like everyone needs to be taught English, and me as a junior English teacher, well, in the making, still in the process of getting my, you know, things sorted out, but I'm getting there slowly but surely. I am kind of starting to get an understanding of why it's important to use the correct language to explain certain things, which can otherwise be extremely misleading. So, John, would you be so kind and just explain what was it that you wanted to discuss in that point, and then we will get Dr. Tom's opinion.
Absolutely. So there's a line that Chris says in the documentary that goes, I'm going to have to paraphrase this a bit, but it basically goes around, it goes like this, essentially, that there was a lucky few dinosaurs that survived the extinction, and they essentially became birds. Now, this is very much ignoring the fact that birds were a very established family, like well before Tyrannosaurus Rex even came to existence. If we go off of the idea that Archaeopteryx is the first bird, then birds were already a thing back in the late Jurassic period. And by the early Cretaceous, and we get to see birds like Ibromasaurus and Confuciusornis, and plenty of birds are already, they might not be the most conventional birds compared to what we see today, but birds were very much a established family during the Cretaceous. And then by the late Cretaceous, you see animals like Avosaurus and Hesperornis, and just a wide variety of birds that come about alongside conventional dinosaurs. And unfortunately, it comes off based on this documentary that, well, birds just sort of, whatever dinosaurs survived the KPG mass extinction just morphed into birds, which is completely wrong. if that's the implication from that statement. And for me personally, this is not very scientific at all, but this is just a personal observation. It gives me the impression that we're just living with dinosaurs now. That because birds are evolutionary, birds evolved from dinosaurs, and that you could argue that birds are a very derived group of dinosaurs. That must mean that we live with dinosaurs, and I think that does two things. One, it devalues the uniqueness of birds from conventional dinosaurs, and it also devalues the uniqueness of dinosaurs from birds, and essentially just ties in dinosaurs as a family to birds, rather than making the distinction that, birds did evolve from dinosaurs, and in a sense you could say that birds are dinosaurs, but birds are still very unique, and dinosaurs as a family are still very unique compared to their modern day relatives. So I guess where I'm trying to go with this is that the line that, there's a lucky few dinosaurs that survived and turned to birds doesn't make sense from a fossil record standpoint, because again, we've got plenty of birds in the fossil record to say that they were a very established group, and they only diversified following the end of the age of dinosaurs. And it sort of plays into this observation that I've been seeing, where it's like, some people just want to say we live with dinosaurs. And personally, I think it just does nothing but devalues birds and conventional dinosaurs as fairly unique groups. But that's my take on this line, and it bothered me because of just how it really muddies the waters when it comes to the relationship between dinosaurs and birds. So I will leave it to Dr. Carr to give his stance on this.
Yeah, like factually, it's incorrect. That specific statement, it harkens to, say, the multi-regional hypothesis of human origins. That major populations of people evolved independently, and we know factually that's not true. We all share a single common ancestor that first arose in Africa and then dispersed from Africa in multiple waves to populate the planet. So saying that several dinosaurs survived the extinction and became birds is not true, because modern birds evolved in the Cretaceous. The fossil record shows this, and molecular data is consistent with it as well. The fossil record is really bad for modern birds, but there's a few bits here and there. And so what he should have said was that, non-avian dinosaurs, including T.rex, went extinct at the KPG event, and the only lineage of dinosaurs to survive were modern birds, which means that all of the other birds went extinct as well, like the opposite birds that you mentioned, like the enantiornithians, all of them. So with regard to how to think of birds, birds are dinosaurs, they are theropods. They're just so highly derived. It does take a bit of extra mental work to see birds and understand them as dinosaurs. And in some ways, with people, it's kind of hard to think of us as mammals and to think of ourselves as primates. But if you spend any amount of time in a zoo observing any primate, it becomes pretty clear that our primate nature is out front and center. We just need a point of comparison. So, and birds require some heavy lifting. They don't look much like T.rex. But we have to remind ourselves that the presence of feathers is a ornithodyryn thing. So just in one glance, that pulls us to the base of that lineage. The fact that dinosaurs or birds are walking on their hind legs, that's a dinosauromorphin or dinosauriformin thing that's going on, possibly earlier than that. And so everywhere we look on birds, we see their ancestry, and really the only thing that's left is their small size and their beaks, their toothless mouths. Those are really the only things we can see externally that birds can claim as their own. None of their plumage, of course. And so the bottom line is, to say that birds are dinosaurs is factually correct. There's nothing wrong with that. To say that they're advanced, highly derived theropods, there's nothing wrong with that. That's completely true. To say that non-avian dinosaurs went extinct at the KPG event is true. There's nothing problematic there. So I don't think there's nothing devalued when discussing birds as theropods, dinosaurs, ornithodyrans, archosaurs. It depends on what part of the tree you're viewing them from. So they have value in that they lift the lid on some very deep ancestral anatomy. But at the end of the day, birds are living dinosaurs, and there's nothing we can do about that. We are literally living in Jurassic Park already. And the only heavy lifting there is that birds really don't look like T.rex. So there's a bit of mental work, I admit. And when I was younger, I had a hard time. I had to wrestle with this birds as dinosaurs fact, because birds, don't look like dinosaurs, but they really do. If we know, about paravians, the dromaeosaurids and troodonids, we know they had plumage, remiges, and rectrices. The basal members were probably flying. Birds, there's not much left that birds can call their own, but that does take extra mental work because we have no other dinosaurs alive today for comparison, which might have made these things a bit easier. But here we are.
It's especially tough to think of it because when we say dinosaurs, we're not just thinking theropods as well, or not only that, but theropods themselves as a very big inclusive group. It has so many different animals. Well, obviously T.rex, then you have other ones like the Allosaurus, Ceratosaurus, Carnotaurus, etc., that have their unique look that makes them almost like, in a way, in some cases, you could say, okay, they may have some constitution, of what you would see in a bird when it comes to locomotion. But on the other hand, they have scaly integument that is more what people associate with, I wouldn't want to say reptilian because birds are technically reptiles by proxy. So in fact, the program makes that because program
by
makes
common
that
ancestry.
Yes, common ancestry. There we go. Yes.
That's the key to everything.
Yep. It's common ancestry that tells us basically that these things, and this is very cool to think of it like that. But then when you start going beyond theropods as well, when you start thinking, okay, there is no animal that is an archosaur that looks like a freaking diplodocus, or not to mention the size of it, or if you're talking about stegosaurus or ankylosaurus, things like these. And I'm talking about specifically archosaurs, because when you start looking at armadillo, for example, you're not really thinking, when you understand what your animals are, you're not thinking, ankylosaurus. You're thinking more like glyptodons, Didicurus. Didicurus is like many times is being memed and joked about as being an ankylosaurus of the mammals because of its tail club, which is basically like a Morgenstern type of tail club with spikes and everything in it. So, but we do know that it's obviously nothing close to what an ankylosaurus actually is. Even if the convergent evolution does give us sometimes the superficial resemblance to a degree, because they were probably playing a very similar role to what ankylosaurids were doing with their armor and weapons. So, but I mean, just trying to think maybe for a second about the fact that Ankylosaurus is related, the modern birds are still very, closely, are the closest living relatives to Ankylosaurus or Stegosaurus, is what is probably the most mind-blowing part. It's not even that they are the closest living things to the theropods, which were bipedal, most, to our knowledge, most, at least. I can't think of any exceptions. But it's more about the other ones that are the quadrupeds, that are these really heavyweight sauropods and armored dinosaurs, even ceratopsids, to be honest, especially the the advanced ones like Chasmosaurians and Centrosaurians, those ones, those things are not your average chicken from the farm, on a down the road. If you see something like that, you would not really be thinking that, obviously. So
yeah, that's the cost of the extinction. We have a depauperate fauna, so we don't see, we've lost most of that diversity in one stroke. And yeah, it's the key to it all is understanding evolutionary relationships, and that is the key to identity. Identity is baked into descent, descent with modification, what Darwin established back in 1859. So relationships are key. And in the documentary, that was a clear wipeout, because only one lineage of dinosaurs made it through, and that was modern birds. So I agree that that's highly problematic, and I wish that the researchers caught that one before it, made it into the film.
they make another very bad mistake, and I don't recall if we have brought this up in a previous part, but just in case if we have, I will quickly rehash it just to emphasize this point more. Is that they are actually saying, they're making rhetorical mistakes where they say reptilian features or bird features, whereas they're basically even making that same mistake, very rookie mistake in my opinion, which I admit to have been making a long time ago as well, before I knew better. But it's that they're separating birds away from the reptiles, which actually is not correct. If birds are dinosaurs, and dinosaurs we know are reptiles, then by proxy, birds are also reptiles. It cannot be. These two things are completely mutually exclusive. They cannot be true at the same time. So, and that's another error that the documentary made when they first made that claim. Then they appear to have slightly corrected themselves when they made a specific comparison that, they said crocodilian versus bird. Like, okay, so you're staying within the Archosauria. That's fair enough. No problem there. And then they again go back and make the same mistake they did before that. And I was just, okay, never mind, back to square one again. So
like, I know that this is sort of the area that, this is how we think. You've learned to think this way. I've learned to think this way. Not everybody does. And among other things, I teach introductory biology to freshman students. And the entire front end of the semester is to train them in cladistics. So it's the modern version of Darwinian evolution, and taking the task of recovering life. And so even after a semester of that, students still find some fairly straightforward concepts a real challenge. So for example, something like, on a test I'd have a diagram, a cladogram, and I would ask, are something like, are platypus marsupials? And sometimes, they'll get that one wrong. Obviously, they're not. Platypus do not belong in that lineage. They're outside that lineage. So straightforward questions like that. And there is some work involved at learning how to read a cladogram, how to understand names, and that names are names of lineages. They actually mark common ancestry relationships. That they aren't just names floating out there. They actually have a very specific meaning. As you said earlier, terminology counts. The language, the words mean something very specific. And it's, so, even for undergraduate biology majors, these concepts do take some weeks to months to really understand. And before they're able to navigate a cladogram successfully and answer some straightforward questions based on a cladogram. So, should we, give the documentarians some latitude there? Maybe, but maybe not as much as we would give students, because the factual statements in the documentary should be vetted before they're aired. So I think, yeah, we can be a bit forgiving, but not much.
I agree with that. I'm happy to be somewhat charitable to take into account that maybe they just, I don't know, it was just a very, what's the best way to describe it? It wasn't exactly, it was like an honest mistake on the language part rather than it was actually meant from their perspective to carry any weight. Maybe they just could have not realized it, that it does actually carry a bit of weight when you are presenting it as a documentary and you're trying to go so deeply technical into areas, and then all of a sudden you're completely abandoning that technicality and trying to oversimplify it again. It's almost like the actual communication language when it comes to this type of medium felt a bit inconsistent when the documentary tries to get highly technical and precise with you, but then on the other hand, it completely ignores some important methodology and the consistency of that precision, which is what stood out to me in that sense, I guess, as a whole for the project entirely.
Just before we leave this topic, one of the best examples of explaining a cladogram in a documentary was done, I think, back in the 90s. There was a really good NOVA documentary on the American Museum's expeditions to Mongolia. And there's this lovely sequence of Mike Novacek, who's a mammalian paleontologist, drawing a cladogram in the side of a sand dune and explaining how birds are dinosaurs. It was just clear and elegant and straightforward because these concepts, they really aren't complicated. Like a colleague of mine and I discussed that, we're puzzled at how students don't really get it, like cladograms, why it takes so long for them to learn their way around them. It's really quite straightforward. And sometimes people just overcomplicate things. And that might be another factor at play here.
Okay, so John, are you happy with the answer from Thomas, or would you like to elaborate or ask anything else on that point before we move on to the next points? Because we've got quite a few to bring up that are very important as well. But you're welcome to obviously, add something if you have something.
I don't have too much to argue about. I'll just say this and then we can move on. I don't mean to imply that I'm against birds being dinosaurs. It's more or less the application of it that I feel like can get by some people that sometimes gets under my skin. I have to remind myself, that there is truth to it, obviously, but and so for this reason, that's why it bugged me so much with the way that they handled the statement in the documentary. But that's all I had to say. We can move on to the next point.
It's like we have to actually remind some people watching here that no, my community are not what are they called them? The abbreviation, the ones that are bandits or something like that, the ones who are basically denying, that birds are dinosaurs. Like, no, we're not it. Just so we can make that loud and clear for, I don't know, 1.5 bazillionth time, in case we haven't already. So the next point I wanted to bring up is the program says something very interesting. And then again, it's hard to say because it's partially true, perhaps, but I will elaborate why I had a bit of an issue with it, more so with the way they did not maybe dive into as much nuance behind it. I think that was my main contention with it. So there is one thing that they've gone into, which was the vocalization aspect of T.rex. Now, it's very clear, and I'm pretty sure that that's very likely to be true, but who knows, maybe we will be proven wrong 180, but it might still be very likely that T.rex did not scream its lungs out, it did not roar loudly so the whole jungle can hear it and announce its presence to its prey that would have probably run away whenever they heard its sound, because, what's the point of hunting if you are announcing your presence like that? But the documentary tells us that T.rex could not roar, basically. Now, the problem that I have with it is that it doesn't actually address all other possibilities of how crocodilians and birds, their closest relatives, basically, can vocalize. And that's actually does in fact range in some cases from a certain type of roaring, just not the Jurassic Park type of roaring, but still could be very much considered to be growling or roaring. And we also have a lot other sounds like hissing, you know, all the other different bellowing and a variety of other things, which, I mean, I don't know if there are any, of course, dinosaurs that could be good candidates for singing, but well, what are your thoughts about this particular point? They were saying basically dinosaurs could not roar, and they produced a certain kind of low frequency type of sound in the documentary that they thought was basically applicable to T-Rex. But I feel like what they've done is basically, it's like they've made a robot and they just applied the same type of replay sound to it, rather than actually try to dive into a more nuanced and diverse way of how they could vocalize to kind of make it a bit more realistic of how there are different ways that animals can vocalize it. And crocodilians are actually a very good example of that as well. They can vocalize like crazy if you really absorb them long enough, I'm sure. So before Dr. Carr, of course, seals the lid here, let's quickly hear if John wanted to add or ask any additional question in regards to vocalization or make an additional comment, and then Dr. Carr will just wrap it all up with a nice bow on top for us.
So my perspective on this is that it's not I don't think it's impossible for dinosaurs like Tyrannosaurus Rex to roar. I think when people try to slam dunk this point, it's impossible to fully prove or disprove unless we find more material evidence that suggests they don't have like the kinds of muscles or the kinds of bones, probably more bones, because obviously the muscles are gone by this point, but the bones that would allow for an animal like that to roar. Unless we were to find something to prove or disprove that, I'd say I would personally keep the file open indefinitely for this. I don't think it would be reasonable to say that Tyrannosaurus Rex was making these insane sounds that it was making in Jurassic Park or any other science fiction film, and it certainly wasn't doing this 24/7 at the top of its lungs. What I would say is that they probably had a variety of sounds, and roaring could have been part of that. Like I do recall there's at least been a few instances of crocodiles actually roaring, like open-mouthed roaring. It's not very common, and it may be only for very specific reasons, but it's not impossible for them to do that. So with that in mind, I'm of the personal opinion that dinosaurs probably had a wide variety of sounds to communicate with one another, to signal territory or to attract mates or whatever the reasons might be. And I think to say that roaring was impossible from the get-go, I'm not sure if that's as helpful as saying they roared all the time, but that's my personal take on it. So I will leave it to Dr. Carr to elaborate more on his perspective.
Right, so when in doubt, put a leash on it. And the leash, in terms of inferring soft tissues and anything else that's inherited that is the product of soft or hard tissues, we can set the null by using the extant phylogenetic bracket. So the extant phylogenetic bracket not only applies to soft tissues, it also applies to behavior. And one thing I have my students do is take on questions like this. I'll pick out some behavior and ask students to bracket it, and what's the null for dinosaurs? So it could be, say, living in groups, that sort of thing, nest building, and so on. And so we can apply the same approach here to vocalization. And so whatever vocalizations are shared between living birds and crocodilians were almost certainly inherited by their common ancestor and would have been inherited by all descendants living and extinct. That's how we set the null for vocalization. And so with that, we might get hissing and chirping, and maybe a couple other things. Certainly not Singing, as we see in songbirds, that requires a very specific type of anatomy and neuroanatomy to pull that off. So if I were a consultant on the show, that's what I would have told them to do, or I would have taken on the task myself to find those vocalizations shared between birds and crocs, and there's your T.rex null. With regard to if Tyrannosaurus could go beyond that, what we need to do is model the soft tissues. And sound production, for better or worse, involves a lot of anatomy, starting with the lungs, the trachea, the bronchi, air sacs. Sound production itself is more or less occurs, at least starts in the trachea, and then is modified in the pharynx, so the region before the open mouth. So we have an oral pharynx, a nasal pharynx, and then the oral cavity itself, the nasal vestibule, which is the space deep to the nostrils. So all those structures are involved in sound production and alteration. And if we really want to answer the question, well, then hell, we've got to model all that digitally. And unfortunately, I think there's a lot, like in terms of, we could, in a straightforward way, bracket those tissues and those structures and their tissues and get some sort of simulation of the actual sound. I don't think that's beyond the pale. It would take a lot of work. I know that a bit of work has been done on this stuff, but when we're talking, lung morphology, trachea, and bronchi, the opportunity for error is really, really great. But we could probably simulate the sound within, certain bounds. But that's what it would take. And that's a couple NSF grants and a lot of time, a lot of computing power. So, yeah, I don't have much more to say on the matter, aside from the fact that the real work really hasn't been done to actually model sounds, scale to the dimensions of a T.rex or any other dinosaur. We've seen people model the air spaces in the skull of Parasaurolophus and simulate what, sort of sounds that crest would have produced. But we have to keep in mind that it's not just the crest that's at play. It's the form of the mouth itself, the pharynx, the back of the throat, the trachea, the glottis, all that stuff. There's a lot that goes into this. It's not beyond, the ability of science to hypothesize and model. It's just hasn't been done yet, to the best of my knowledge. It's a lot of work, I expect.
Yeah, I suppose, well, it is going to take a fair amount of time and quite a lot of determination from the right people as well to be able to actually conduct all the necessary data collection on this and all the...
Yeah, I think the anatomy side might be straightforward. I think the digital modeling might be where the heavy lifting is. That's just my intuition. That's not the sort of thing that I do. And if I recall from the documentary, I don't think they had really modeled any T.rex anatomy. You can remind me, didn't they just lower the frequency of a hypothetical sound? Wasn't much beyond that, was it?
I think they pretty much used an alligator, if I remember correctly. It's obviously been quite some time already since I've watched it, but and I mean even prior to the program, because it's been maybe only like a few days before we did a recording last time, but obviously prior to this one, you know, my memory is faded a little bit, so don't quote me on what I'm about to say. But what I will say is that it was fairly simple. It didn't really go into the nuances of actually trying to model the skull itself and try to see how would these muscles go there, where it would go, how it would come, you know, come together when it comes to modeling the throat space and how the airflow would work, how would the nasal maybe even work and all together. And basically all of these things, as far as I know, were not even really nuanced in that sort of detail. It was mostly just taken what they thought was a very close equivalent, like an alligator, for example. Well, I think that's what they used, it, or a crocodile or an alligator, and they started just basically lowering the frequency, presumably based on how it would increase if there was an animal of a T.rex size versus something an alligator size, which I don't even know how applicable that would be. I mean, I would even doubt whether or not how accurate that would be, even if they were to model something like a Dinosaurus or a Purosaurus, the Brazilian giant caiman. I mean, I would probably argue that even they could potentially have been able to produce a unique set of sounds for their own maybe species or whatever. So it's definitely a nuanced issue, and I can definitely say this part you can definitely quote me on that. In regards to nuances, they did not quite do the legwork to actually show that.
Yeah, unless there's, I can't recall, like, unless there's some scaling relationship in crocodilians, then, you know, scaling that up to, you know, T-rex size, I guess makes sense. I mean, that would be the only thing available. And also just to acknowledge, you know, the Jurassic Park sounds, as we all know, those are amalgams of several animals blended together to produce that terrific roar. And of course, no animal sounds like that. You know, it's complete fantasy that those are so many different anatomies and evolutionary histories like overprinted on each other. It's, you know, there's no way that any extinct animal would sound like that, given the approach taken to produce that sound for the movie.
Which is very interesting because they have used, I believe, a combination of sounds with the elephant, tiger, probably lion, probably something else, because even the T-rex sounds, because obviously T-rex is famous for the iconic roar that it makes at the end of the first film. That's its basically super prolonged one. There are many other types that it makes, which are a lot different from that one as well. But the ones that never almost ever get brought up are the ones that we see in the second movie, if you were to ever rewatch the 1997 second part of the franchise. You will notice that they sometimes make these shorter sort of outburst type of, almost barking type of sounds, which I was thinking, you know what, this kind of actually strikes me, you know, somewhat with something that I can believe more than when they actually try to go completely crazy into screaming their lungs out, you know, like crazy, like they done, you know, prior to that. But it was very interesting to watch how they actually made them produce some variety of different type of sounds in the second film, because they have a pair of T-rexes, and in fact I think even the male and female, they made them make slightly alternating sounds. Some of them were similar to each other, otherwise they would be slightly different, but that was very interesting as well to look at. So if you do watch this film again, do pay attention to that part as well if you're curious. So is everybody else happy with the vocals? Can we quickly move to the next part? Okay, John?
I'm good. Yeah,
yeah, we're good.
I'm good.
Okay. So the other one I wanted to look at, and this is a very interesting one as well. It's let's look at the coloration. And boy, oh boy, can we go to town with that, because the possibilities are literally, what you might think they're limited to certain options based on even the extant phylogenetic bracketing. But you might also think, but wait a minute, that's still a lot of options. So now the program, I'm just trying to see where it is that they say yes. So I felt like the program was a little bit vague when they started addressing that. So first of all, they were not really demonstrating, their understanding of how the reptiles are in general and how they use their coloration and how they see. So they don't actually make a point about that, which I think was a missed opportunity to show that what we see in today mammalian megafauna, for example, is quite easily could be hypothesized as the way it works based on how mammals see each other, for example, right? But there is also an aspect of when you look at dinosaurs and their ecosystems, which are dominated by the likes of their own mostly, we're looking at it from the point of view of how the reptiles would see. And what does that give us in terms of the options of how to explore their coloration and what it would basically produce as a result. And bearing that in mind as well, they're using this, what was it, the eagle or hawk? For some reason, they decided to use a bird that was basically a bird of prey, presumably, but I have my own peeve about using birds of prey as comparison for any of this, mainly because they're just so unique and derived to the point that they are, in fact, I think in evolutionary history, are the first ones who show the reverse sexual dimorphism, which we don't see anything even outside of, we do see it in the aves, we do see it in other species as well, not just birds of prey, where it's more common, but outside of aves, we don't see this in archosauromorphs that we can think of. We know that crocodilians, for example, they have a completely different form of dimorphism, and that goes the other way. And we also know that in birds, it's either usually difference in coloration, or it's most commonly actually males tend to be larger and more prominent in certain features and their stock, robust factor. Then you have others that go in reverse, which is where it narrows down quite a lot. Which means that we are going to struggle when we try to apply these kind of measures and understanding of how that would affect their color, when we look at dinosaurs. Now, I kind of thought that it would have been nice if they explored maybe colorations of different species of crocodilians, because dinosaurs did, in fact, live in a lot of swampy lands, which were a mix of swamps and different other types of steppe climates, if you will. Sometimes more denser vegetation, other times with slightly more open areas, all different ones, but swampy areas were definitely go-to places because I'm pretty sure there was always a lot to do, let's just say, in the swamps. So quickly, John, do you have anything that you wanted to add on that note before, once again, Dr. Carr is going to wrap it with a bow on top?
Well, I'm not an expert on finding out the exact colors in dinosaurs, and really, and even modern animals. I'm still a little still learning about that. So I'm going to try and avoid saying anything that makes me look like a complete ignoramus. But my personal view is that they went for birds a bit too quick for my liking, and my reasoning for that is birds of prey just have, like, the way they operate as hunters is just vastly different from that of a theropod dinosaur like Tyrannosaurus Rex. And to be fair, the coloration that they give the T-Rex in the documentary isn't it's not bad, and I can actually believe it for an animal like that in real life. But I feel like you could have come to that same conclusion if you had stuck with crocodilians as an example. So for me, it's like it's just a little curious that they immediately went for birds in this case, rather than try to compare both and see which one would which group would probably make more sense for Tyrannosaurus Rex in regard to its coloration. Because again, you're dealing with an animal that is a very big apex predator that was probably moving around in a very mostly tropical environment, and its hunting style is not going to be like the same thing as what a bird of prey is doing, and it would need some kind of coloration to match its environment and camouflage and whatnot. So again, I think the way the documentary the color scheme they gave T-Rex in the documentary is fine, but I feel like they could have explored that more, and they just sort of just went straight for birds and called it a day. But that's all I have to say on that note. So I will give it away to Dr. Carr.
I'll try to be quick. Yeah, it's kind of, well, I guess I'll answer it this way. I'm currently involved with a group that does digital models. And we're doing a digital model of Jane. Basically, it's my vision of what Jane and a young T-Rex would really look like. And in terms of color, you know, there's just a couple basic rules to follow, and then it's just, you know, the bracket doesn't no longer helps. And so for big land animals, I think counter shading, I think, is the only thing that we can count on being accurate. So counter shading is being fairly dark back and sides and a pale belly. And that's basically, you can see that across most animals on the land and also in the oceans, and then beyond and in water. So beyond that, it's fantasy. But what my approach that I take is to base coloration in Tyrannosaurs and other dinosaurs on their closest living scaly relatives, and that's crocodilians. And since there's a lot going on Tyrannosaur heads, lots of subtle horns that are growth variable, I tend to have the heads of reconstructions reddish. So that's like a Cuvier's dwarf caiman, a coxcomb of fowl, you know, chickens, that sort of thing. So I treat the head as colorful, mostly a brick red. And then the rest of the body I'll base on a crocodilian that is ecologically matches the animal. So, you know, for animals that are in a tropical, forested type environment, the saltwater crocodile is a good candidate. You know, it's sort of pale gold with dark spots. American alligators being an overall steel gray. That might be another candidate, but the juveniles would be more bold in terms of coloration. And I take that basic approach that the juveniles are bolder and brighter than the adults. So I use crocs as a point of reference, some basic rules that are also seen in birds, like drawing attention to the head with reds. Crocs do that too. And I try to ecologically match. So there is a leash on the inference, but it's not a very tight leash. But I don't allow myself to go past the leash. So I'm not about to give, you know, iridescent streaks or bright pinks, that sort of thing. I stay pretty close to what we understand might be the constraints on large scaly archosaurs and crocs. That's the best source of information, the only source of information we have. But that's my own particular approach to these things.
So in this case, would you be happy to take a look at some examples that I have compiled for the presentation slides?
Okay.
So, well, starting from this one, this is the programs one on the left, and this is the edited version on the right by, you can see Fred the Dinosaur Man. So what are your thoughts about both of them, in fact, and how well do you think each of them did it? And then, of course, I'll show you some other examples that I think would be very nice mentioning.
Well, I think, you know, the bottom line is I would have suggested a brick red head, and then you know, maybe the color and pattern of a salty or a Nile croc. That would be my approach to T-Rex in general. I wouldn't be saying anything different. So for these, this isn't what I would have done.
Okay, well, let's try to see if something else gets a bit closer to to that model. Of course, I don't have the perfect examples here, but speaking of, by the way, the Cuvier caiman, you will probably find it very fascinating that, well, aside from the fact that they're literally the crocodilian version of dragons alive today because of how they look, project that image briefly on a Tyrannosaurus Rex. Well, for the sake of being avoided to be called, you know, fantasizing too much, you know, when projecting my fantasy fetishes onto the T-Rex, you know, the reverse argument, if you will. I'm just going to leave it up to the imagination of the viewers. But there are a few interesting things about it that apparently it's considered to be, for the modern day standards and being alive today, it's a very understudied species, the Cuvier dwarf caiman, in terms of it hasn't been quite as frequently observed in its natural habitat for what we would probably like to see. But the interesting things that I did notice those things that stood out to me quite a lot is that their individual variation is actually quite variable. And they have basically, like what you described, is basically the classic representation with a brick red head and the darker gray, or usually sometimes even going as far as black body. But the other times I've seen several specimens of, well, photographs of them anyway. I haven't seen them, unfortunately, in person. They are all the way black. And I mean, as in, like, they do have patterns, they do have gray parts and everything, but I mean, their heads are also black. Or sometimes their heads, they go like a beige sort of gray, which is very interesting because of all the different structures on T-Rex that could potentially be highlighted. You could probably think that that could be a very nice an interesting projection, if you will, on how it would work on something like T-Rex. But let's take a look at another example I've got for you. And this is, I will explain to you once I share the screen what it shows so that you have a bit of more context. Let me quickly grab that screen for you right here. And here we go. So you've got quite a lot going on here. Now, the ones on the right is a bust. Both of these, by the way, models were made by the same artist. I believe both of these models are considerably old, with the one on the left has been slightly updated with just the posture, I think, and the legs. And I think he has corrected a few issues with the fenestry, but I'm not 100% sure on that part. But it's very interesting that the one on the right is kind of interesting how it varied with your ideas when you said there was like an armored like skin. So I suppose the one on the right has decided to take it to a bit of a next level to a degree, especially of the distinctive coloration that it gave on the tip of the snout and how it blends with the nasal and the lacrimals, etc. And then you have the ones on the left, which, as you can see, they're a little bit simpler in that regard, but they have one of them is portrayed as an albino, and the other one is basically, well, the light bronze green-ish with a darker head. So what are your thoughts on this choice of the artist?
I mean, they're as reasonable as they could be. But again, I'll say this is fine. It's just if I were a consultant on a doc, this isn't what I would suggest. So I like my approach. It's pretty, it's kind of boring. And it's just this, it'll be the same answer each time. They're interesting, but that's just not the point of reference. So
fair enough.
I'm pretty strict with using Crocs as the point of reference, which, you know, I think it's the most reasonable approach. And it's anchored in common ancestry and integument type. And it may be completely wrong, but I think it's at least a phylogenetically constrained point of reference. You know, and the reason why Cuvier's dwarf caiman is it's, I think, the only crocodilian that produces anything like red. And that's the crocodilian red. It's sort of a brick, sort of, you know, ranges from a brick to a tomato type red, a very dark brownish red. And
you could almost go as far as saying like it sometimes gives this kind of dull copper sort of red look in some cases.
Yeah,
if
there's
you were to go with
variation
extreme.
there. And so, so I think like my position on coloration in dinosaurs is there has to be a consistent, defensible point of reference that, that's phylogenetically justified. So I'll just be saying, I don't need to see anything else because I'll just say the same thing. A Cuvier's dwarf came in head with whatever body ecologically matches the animal of concern.
A different dinosaur, of course,
Yeah.
but I think that gets closer slightly to where you were leading up to. I just don't have any good examples of that, something that matches anything, because I haven't actually done any of my own pieces that would actually match your description specifically. So I have yet to actually find myself a kit of a theropod, which actually I do have spare, but I haven't got around to painting them yet. Then maybe next time I could show that off. But this is the reason I brought this one up here is obviously we are going to ignore for a moment, at least if we can, that this is Allosaurus jemansoni. This was released just as a supplementary illustration done prior to when it got described.
Mm-hmm.
Now, the interesting thing about it, of course, and that's the reason why I really took a liking to this artwork, is because of how interestingly certain features have been proposed, let's just say proposed to look here. And one of them was the coloration, which I recalled did match your description, which you have given me ages ago as well, with a more reddish tint towards the head, and the ornamentation, especially if you notice the crest, especially they get really, really strong red. And the other part is notice how the lower jaw appears to accommodate the position of the upper teeth when the mouth gets closed. So it's not a lipped model, basically. It's actually a lipless model in that sense. But I was kind of thought I would bring this to your attention a little bit in regards to how the artist, what was the choice, of the depiction. And if you've ever seen something like that, and what are your thoughts on this kind of choice of depiction as well, in regards to how this works together, basically, if you will.
Yeah, I think, I'm not an expert on Allosaurus, but I think, I wouldn't do too much differently with this. I think the nostril I'd push forward and down a bit. I don't think you would see the anterorbital fenestra, the outline of it. So that's one thing in Cardall 2017 that's deliberate. We don't define the margins of the fenestra because there's no reason to. There's an air sac there. There would have been connective tissue lateral to that, dermis, then the epidermis, and the head is a single coherent unit in terms of the integument. So you wouldn't necessarily see the edges that are so often emphasized. But yeah, I'd have to, it's a nice reconstruction. It's real, there's a degree of realism.
And the last sample that I wanted to share, of course, this is obviously Tyrannosaurus Rex itself, so no other parallels or comparisons. This is just basically something I could pile up to just what I thought was just generally decent looking, because everything else I was looking at, unfortunately, in this day and age, just doesn't quite add up. And those were, I think, the best ones I could master, which, for good or worse, unfortunately, you could say that they will have their errors probably if you were to start looking into the nitty-gritty bits. But
yeah, so I think the bottom line for me is, it actually was reached by the production team of the Acum documentary, and my advice was, and I'm not sure if I mentioned this before in a previous conversation, but I guess I'll repeat it here, is I told the producer that make sure your artists get the head right, and because that's the cornerstone of everything. If you've got that wrong, then there's no coming back. There's no recovery. So, I mentioned, I recommended that they even surface scan a skull in the UK. There's casts of Stan and also 5027, the New York skull, so that there's stuff to work with. But you have to get the head right, at least for me, or else all I see are the mistakes. So with the prehistoric planet, there's just basic stuff with the head that was wrong. And that's all I see. That's not the face of T-Rex. And unfortunately the case here with the Pachym Rex, that's not the face of T-Rex. And it's not hard to capture it. You just have to do a bit of work to get that right. There's another trend I've seen in terms of paleo art, and that is that all the animals look like they've been dead and lying on the side of the road for a while. They all look like balloons. They're all puffy, and there's no definition of the muscles. And when we consider living reptiles, large reptiles that don't have the osteoderms and scutes in their skin, so I'm thinking large foranid lizards, that you have definition of the muscles. You have definition of the intervertebral or paravertebral muscles. You have definition in the tail, in the legs and arms. And I think for dinosaurs, you would see that, like even large mammals, like if you've ever been close to a horse or even a cow, you can basically label them. You can stick labels and identify the muscles. And it's just a bizarre trend that people sort of make T-Rex look like a balloon and not define the muscles. So with the reconstruction of Jane, I'm making sure that major muscle groups are defined, that the animals look powerful because they were. Young Tyrannosaurs were cursorial. They would have had, defined muscles. It's an eat or starve lifestyle. So these aren't animals that would pack on a lot of fat reserves. Most of the time, there probably wasn't enough to eat. There'd be barely enough to eat. And so these fat T-Rexes are really well-fed animals. So it just doesn't seem realistic, at least to my eye, to have these really well-fed animals without defined muscles. They should look toned. That's the word I'm looking for, is that big reptiles, that non-crocodilians, they're toned. And the crocodilians look kind of fat and puffy because they have very large scales and osteoderms in their backs, and that obscures the true underlying form somewhat. And so I think the Pachym Rex also looks a little bit rotund as well. There's a definition or tone that that I would expect to see of an animal of that size and behavior.
Well, it's very interesting when you mentioned the roundness trend, and I was about to make a very, very, very cheeky joke, and I will probably do it. It's that, guys, can we just not project our desire to not go to the gym and instead spend all that time in McDonald's? I understand cheeseburgers are nice and everything. I do love my chicken McNuggets too, as somebody who almost never goes to McDonald's, by the way, so you don't just call me names for that and saying you don't understand. I do understand. Trust me, I understand. But dinosaurs did not go to McDonald's. Dinosaurs probably were very, 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 well, let's just say, they were not as spoiled, let's just say, with the choices of food when it comes to these kind of things, and every piece counted in that environment and in that sort of setting. It's just, not to mention that something the size of Jane could potentially be a good item on a menu for another rogue Tyrannosaurus Rex just as well. It not necessarily means that it would just be able to protect itself from something as well that big, even from its own species, so there's a lot of things to worry about, and I'm pretty sure that all contributes to the fact that no, they were not round and balloony. I don't even know how it would actually work if they were, to be honest. If we were to actually try to be charitable to this idea, how it would even work for them. I struggle to imagine how that would land.
Yeah, the final point is I've been fortunate to see large animals up close. Including ostriches, and the bare part of their legs. Those are powerful looking structures, and they are. I went to an ostrich farm in Ontario, and there was, some adults close to the fence, almost 10 feet tall, looking down on us, very intimidating. And the farmer had a dog, and the dog was running along the outside of the fence. And the ostriches were really upset by this. And the male kicked the ground about 10 feet away from us. And I felt the tremor. It was just an incredibly powerful kick. And it was just, for the ostrich, it was just tapping the ground out of irritation, but incredible power. Where we do field work in Montana, we're on a farm, on a ranch that has beef cattle and horses. And those are large mammals. And up close, as I mentioned, you can basically stick labels on virtually each muscle. They're so well defined and clear in animals of that size, especially bulls. Though I do realize we're talking about mammals, which are a slightly different story, but still, I think the tone, muscle tone is present. And also at zoos, I've been really up close to a giraffe, and they're just mesmerizing on their own as giraffes. They're just the most incredible animals. I think, all I can think of is sauropod, with a giraffe in front of me. They're amazing animals to see up close. But also there, the muscles are toned, that their hair is fairly short, sort of like cattle or horses, and you do see through that. You get the muscle tone, and you can virtually identify all the muscles in the arms and legs. There's no substitute for seeing fossils in the round, like going to a museum and getting a really detailed understanding of skull structure. And then in addition to that, going to zoos and observing large mammals and getting a sense of the relationship between size and the anatomy that you see at surface, because it becomes distinct in big animals. In elephants, less so. I've ridden an elephant, and they're a bit of a different story. But my bias is to think of young Tyrannosaurs and the old ones as having very good muscle tone.
John, do you have anything to comment on this point? Because I do believe you might have had a few things to say on that.
Well, I know I brought up a couple things in our first collab regarding Tyrannosaurus Rex depictions, and more specifically the thick Rex, as I think has been a common trend as of late. For me, it's, like Dr. Carr said, if you make a dinosaur that big, especially a carnivore that had to be a lot more active in finding food than most herbivores, I'm not sure they would be that big. They would probably be very fit, very muscular animals, and I don't think they would have looked, I guess the word that my generation uses is chonky. I don't think they would have been that chonky unless they happen to get very lucky and they found a whole bunch of carcasses from which to scavenge from. But no, even Tyrannosaurus Rex, which comparatively speaking has been described as a relatively more robust or stockier large theropod, it wasn't, just because it would have been a bit more stocky or robust compared to something like Giganotosaurus or Carcharodontosaurus doesn't necessarily mean, or even Allosaurus, doesn't mean that all of a sudden it was now this big rotund creature. It was still fit. This is an animal that was still very fit, and I would say well-toned muscle-wise. It just had a bit more going on, and partially that's because of what it was hunting and what it was hunting. So, and how it was going about killing things. So Chonky Rex is cringe, and I'm so glad that Dr. Carr roasted that one. So, but that's what I have to say on that.
Cringe and arguably sus.
Yes, exactly.
So this is the reason I brought this image up, and this is actually a model from a game called Prehistoric Kingdom that both me and John like and plan to review sometime on the channel. We have already exchanged notes, guys, so those who are watching, stay tuned. Once we obviously get around to it, we will try to adjust our notes accordingly to keep up with the development pace and everything. But this is actually a in my opinion, what I think matches the description of a Tyrannosaurus model, which they use in the game, that is not chunky, overly chunky at least. You can see that it's quite lean, and there are certain definitions present. You can even see it on the tail, I think, quite well too, and on the legs especially, and on the neck as well. You could, when you look at the reflections and definition. So I think that the reason why I shared it is because it was just something that came to mind, and I thought, yeah, let's actually throw this in there to just give a good example of how it can be done. You know, I'm not saying it's perfect. It doesn't have to be like perfect, because again, define perfect anyway, but it's close, I think, to being somewhat reasonable. But that's, again, my view as well. Dr. Carr, what do you think of the model?
Yeah, I think that's toward the reasonable end of the spectrum. You know, like, you know, the point here is we really don't know what they look like, but we can put a leash on our inferences. And, you know, and so I just want to make it clear to folks who are listening and watching that the point of reference for me will always be reality, you know, and to use large living animals as a point of reference, it's not perfect, you know, because, you know, we're outside of Archosauria, we're getting at these details, but, you know, they do indicate general trends and general rules, and it's not just pulled out of thin air. That's the important point here, is that our claims have to be anchored to reality in one fashion or another. We just can't be making stuff up. And that's my guiding principle, is don't make anything up if it can be avoided.
I wanted to also clarify this so that people who are the cheeky sort of viewers who will try to use this argument saying, so are you trying to contradict your previous argument and say that now we can actually look at it and think, oh, maybe we can still apply lips because tetrapods of today do still all have lips in one form or another? No, no. We're talking about muscles of the body itself, the locomotion right now. We're not talking about soft tissue restoration or facial soft tissue restoration, guys. So let's keep it very, very neat and clean on the shelves here. Just thought I'd point that out a little bit in case somebody has funny ideas and tries to use this as a kind of counter argument or an attempt to paint myself and people here as somewhat hypocritical, which we try not to be to the best of our ability, at least I would say that much.
So each of these questions are different questions, and the EPB, extant phylogenetic bracket, has limited resolution, right? We may absolutely be missing the information we need, and so we have to accommodate different evidence, perhaps resulting in a weaker hypothesis, but we have to work with, we're limited to what we have to work with, and it's not a slam dunk every time, but still that doesn't mean that we can make things up, and each claim is, you know, is independent, so there's no, the accusation of hypocrisy doesn't fly. It's just, you know, we have no reptiles the size of dinosaurs alive today, and so, well, we've got to move out to, you know, Komodo dragons and move out to large mammals. You know, we're not making a, you know, we don't default to fantasy. We default to the next best model.
So if everybody's happy with these points about, okay, great. John, you're happy?
Yep, I'm happy.
Okay, let's talk about the quick claim they addressed as well in regards to teeth. That should be an interesting one. Now, the program actually states that, and I am going to read the verbatim, literally. I copied it in my notes exactly how it was said. T-Rex teeth weren't sharp at all. And I find that this quote lacks clarity and context, because obviously, if you're going to compare it to like your sushi chef knives and katanas and whatever else, swords, razor blades, yes, none of the theropods' teeth in that, for that metric, would have counted as sharp. But we probably can reasonably conclude that we're not comparing them to that. We're comparing them to perhaps other animals and other theropods that have teeth. In which case, is it actually fair to make that claim, given that I've seen T-Rex skulls up front too, and I've seen T-Rex teeth. I don't know. To me, Tyrannosaur teeth just don't strike me as these kind of roundy, blunty, completely objects. They almost are, maybe they're more robust than others. Perhaps they might have slightly different shape and cross-section than other theropod teeth. You could make that argument, but to me, they didn't stand out as not sharp in comparison. In fact, I thought that they were pretty much just as sharp as any other theropod tooth. But that's to me. John, before, of course, we get to Dr. Carr's final wrap-up, bow on top thing. John, what do you think about the claim of Tyrannosaurus teeth were not actually sharp?
So from my experience, Tyrannosaurus Rex teeth and that of other tyrannosaurs that had similar teeth in the same sense of being more rounded or a little bit blunter than what we see in giant Carcharodontosaurs or Allosaurus or even Dromaeosaurs. Pretty much most other theropod dinosaurs are more blade-like, whereas compared to Tyrannosaurus Rex, T-Rex's teeth I would say compared to other theropod teeth, they're a little bit more rounded, they're a little bit more blunt, but they still have serrations. These are not like just spikes necessarily. I mean, I grew up being told that Tyrannosaurus Rex teeth were a bit more like railroad spikes than steak knives, but that's not to say that these teeth were just spikes without any kind of ability to tear through flesh. For me, I feel like the description is oversimplified and doesn't really highlight why T-Rex had the kind of teeth that it did. This was an animal that was applying very, very high bite forces towards animals that had either armor or very tough skin, and was doing this to crush bone and to demolish armor. And that doesn't mean that the teeth necessarily are not sharp. It's that they're designed in such a way that they're not necessarily to be one-to-one with steak knives necessarily. But if Tyrannosaurus Rex were right now outside and decided to chew on my car, it would absolutely puncture right through. And it doesn't necessarily matter that they're comparatively more blunt to something like Allosaurus's teeth. They're going to be sharp enough to leave holes, and if it were to bite into a large animal, it's still going to leave some kind of mark, especially when how fast those jaws are going to be clamping down. They're still going to go through. They're still going to be just as capable of doing damage as other theropods. It's just they have the added bonus of being bolstered by humongous jaw muscles, and those teeth are going to be better built for going through tougher skin or tougher armor. But that's about it, really. The description that they weren't sharp is, I think it's not completely appropriate, but that's just me. Dr. Carr, if you have any thoughts, I will leave it to you.
So sharpness can mean one of two things. Is the tip of the tooth point at the apex, or is the cutting edge of the tooth sharp in a material science sense? So to take care of the first one, if you took a tooth of an adult T-Rex from anywhere in the trunk and sort of lightly stabbed yourself with it, you wouldn't hurt yourself at all. You wouldn't break the skin at all. If you took a needle and did the same thing, you drive the needle, into the palm of your hand. So in that sense, the tips of the teeth aren't sharp at all. You would have to work really hard to drive a T-Rex tooth through your hand. And there's the other question of the cutting edges. And like most theropods and Archosaurus, Tyrannosaurus have ridges on the leading and trailing edges of their crowns that go from apex to base. And in full adult Tyrannosaurus, including T-Rex, those ridges have denticles. That's a word that means little tooth. They're informally called serrations, so the jagged edges on a steak knife. And in Tyrannosaurus, those denticles look like little axe heads under magnification. And in fact, they look like fat axe heads. And the sharpness of such things can be tested in a materials science kind of way. And that has been done by a scientist named Bill Abler, who made a rig to compare the sharpness of cutting edges of various things, including steak knives, butter knives, shark teeth, and theropod teeth. And he was able to examine in a very detailed way, under magnification, the cutting ability of these edges and compare them. And to make a long story short, if I recall correctly, Bill concluded that the cutting edges of T.rex teeth were no more sharper than a smooth, dull blade. That's a butter knife without serrations. And he hypothesized that the presence, if the denticles weren't cutting tissue, if that wasn't the primary function, it could be that the presence of the denticles were to give the teeth a bit more friction, a bit more grip on whatever was being bitten. I think this work also resulted in the grip and rip hypothesis for how denticles actually cut. And so, like I mentioned, denticles in Tyrannosaurus look like a row of axe heads end to end, so long end to long end. And I think at the scale of contact between adjacent denticles, muscle fibers get trapped in the very narrow gaps between denticles, and then they get gripped and then ripped as the tooth continues on its way. As John pointed out, the bite of Tyrannosaurs is off the scales compared to other theropods, and their teeth didn't need to be sharp, neither at the apex, and the denticles didn't need to have any cutting ability because it was sheer power that drove the teeth through their prey. If you've ever played with crocodilian teeth, baby croc teeth are very pointed and pin-like. You would be able to drive a baby alligator tooth in through your skin. They're that sharp. But in adults, they're like mammalian canines, which is also what T.rex teeth were like in the adults. And it was just power. As you know, crocodilians have the highest bite forces among terrestrial animals, and it's just sheer power that drives those spikes into their prey. And alligators can, they treat turtles like a nice crunchy snack, and they actually have malariform teeth in the back of their tooth rows to help pull that off. But to say T.rex teeth weren't sharp is accurate, but you have to explain what it means. And if they didn't explain that the teeth are blunt compared to something like a needle or a baby alligator tooth, and also the cutting edges didn't really cut, those are important points that should have been made if they weren't.
But with that sort of model that you have described at the end, when you were applying the test, of sharpness, I found it interesting because what if we took, for example, I don't know, just trying to think off the top of my head, like an Acrocanthosaurus tooth or a Carcharodontosaurus or even an Allosaurus tooth, and try to apply the same model as you compared to even the alligators and mammalians.
Yeah,
Would it be fair to say that they were much different in that regard, at least?
Yeah, sorry to step on you.
No worries.
In the article, Bill, I can't remember, I know he did test the cutting ability of other theropods. I don't recall what they are, but I do recall that Bill included shark teeth, I think even the tooth of a great white. And if any of you out there have ever played with a shark tooth, those things can cut, whether they're serrated or not. Like they're like playing with razors. You have to be careful with them. And so I think Bill did conclude that shark teeth really are sharp. They really do cut through tissue in the way that theropod teeth don't. They're more like a sharp steak knife. You know, they're at that end of the spectrum, whereas T-Rex is, you know, basically a butter knife. You know, so the railroad spike analogy is a good one. I think more accurately, a mammalian caniniform tooth is more accurate. Those are subconical, powerful teeth for delivering high bite forces, for gripping and penetrating. And nearly every single tooth in a T-Rex's head and a crocodile's head does that. It's a mouthful of canines, basically. And so they don't need to be sharp, either in pointedness or in cutting ability, because the power's there. And the tooth shape, as John pointed out, can take high bite forces, can take the high bite forces, can penetrate through bone. So we know that T-Rex could bite into thigh bones of Triceratops. So Bill's work, I think, is pretty important in establishing sharpness of denticles on teeth of various animals, including T-Rex.
I found it particularly interesting that, and I agree that I have in fact held, not necessarily played with shark teeth, but I have held a few of them there and then, of various sizes as well. And interestingly enough, of course, as they get bigger, they feel less sharp. So that might be potentially consistent with what you have pointed out about the alligators and baby alligators. Because obviously sharks do have quite a power in their bites too, even though their jaws probably are not quite as, generally their body plans are not designed to be as mobile as, say, a theropod body, which can move and twist and turn in different ways, perhaps.
Well, sharks, like whether it's a 14-foot tiger shark or a 3-foot dogfish, their teeth the tooth row functions as a single tooth. And so this is how sharks take those clean bites out of prey. If you've seen footage of great whites taking hunks out of whales, the entire tooth row acts like a giant tooth, and it's very sharp. And it does have a huge amount of power, right? Their bite forces are high. And sharks do shake their heads and twist around to cut through their prey without any damage to themselves. I think it could be argued that they're more agile in some ways than Tyrannosaurs. It's just they have the sharpness in their favor. Tyrannosaurs just don't have that. For them, it's just brute force. So I think, a T-Rex would just bite an animal. The bite forces are so high that the entire rib cage would just collapse instantaneously, and the animal would both suffocate and hemorrhage to death simultaneously. It wouldn't have been pretty.
This is very interesting as well, because I've completely misjudged the point about how actually well the water helps the sharks to propel themselves when they're taking those bites, because they're not just doing it with their jaws alone, obviously. I mean, I should have really taken that into account, that they're using their whole body. Well, I mean, what are all those fins for, right? Yeah, of course they do.
It's a classic death roll. Yes. Sharks do that as well.
Yep, that's right. Or how the cats, or the canids, they basically, when they bite, they also use their body and their legs to take a more kind of solid, grounded posture, so that if the prey is trying to escape and struggling, it provides a better resistance and can apply a bit more for a counter force, so that if it tries to escape, the teeth are also ripping into flesh and basically doing all these nasty shenanigans to them to accelerate and enhance the process of the killing. And T-Rex hunting would have been an interesting sight to witness, especially seeing if it caught something that is a little bit smaller than itself, something like a Leptoceratops, just wandering around unsuspectedly, all of a sudden gets just chomped on by something like a T-Rex.
It's kind of funny, the bite force estimates range between, by analogy, the bite pressure by analogy is equivalent to the weight of a small car at the low end and the mass of a blue whale at the high end. And no matter where you are on that spectrum, if you're bitten by a T-Rex, you're going to explode.
I mean, it doesn't matter which way it goes. Yes, whichever way it goes, you're dead. You're basically very dead. I mean, you'd probably die quite just as easily from a bite from a different theropod as well, even if it's not a T-Rex. So I would probably assume it's safe to say that no matter where T-Rex lands on that spectrum that you have just exemplified, that's pretty certain death. Now, the interesting thing that I would like to transition in regards to bite force is how they used, what they used as their methods on bite force measurement. And that's where I think it gets interesting. I don't know if I necessarily have criticism, more so just to ask the question and what your thoughts are, both of you, in fact, on how they applied the robots when they were using the tooth to crack the bone. Whereas I have heard some people criticize the choice that they used instead of, like they said they used, I think it was a cow instead of something that some people have said that it might be better if they've used something a bit bigger of a size equivalent, like maybe an elephant skull or something like that. Now, this is where I want to know a bit more nuance. So first, let's see what John thinks, and then, of course, you will be able to conclude what you think about these kind of experiments and how you think they could be improved to give us better understanding, to even demonstrate for the eyes of the viewer. So, John, would you like to go first? And then Dr. Carr will obviously elaborate as a final sort of expert opinion.
Sure. I'm not against the cow bone in practice. I think it would have been helpful if they showed more kinds of like different sized bones instead of just sticking with the cow, because obviously a Tyrannosaurus Rex, powerful as it was probably not going around hunting fully grown Triceratops or Montosaurus or Ankylosaurus all the time. It was probably going after relatively well-sized, but still subadult animals of those species, because again, when you get the full-grown animals with horns and clubs, and even in Montosaurus with how big they can get, that's just super dangerous. And so a Tyrannosaurus Rex probably going for a cow-sized subadult and Montosaurus, I could see happening more often than a fully grown one. But at the same time, I think if you were to use larger bones, you could show how powerful T-Rex was when either taking on a larger individual dinosaur, or if it was just scavenging and it was trying to get after the bone marrow inside and whatnot. And I think the documentary would have benefited a lot from having a variety of sizes and then having the tooth come down on all of them to see what that would look like. The fact that they sort of just went with the cow and said this is what a typical T-Rex prey item would have been like, I think limited what they could have shown. But I'm not against it in practice. I just think they could have done more with it, given that T-Rex was biting into anything of any size, really, given what we have material-wise and what it probably was doing when it was alive. But that's my take. Dr. Carr, feel free to share your thoughts.
Sure. I think, so this is a material science question, and bone is bone. Bone has an intrinsic strength limit, and that might be a little bit different between, fresh bone that still has a protein component and dry bone, but the difference probably isn't all that much. And I think the point of the demonstration was to show exactly what sort of damage a T-Rex can do and the forces required to drive a tooth through bone. And so it almost doesn't matter what the bone was, as long as it was sufficient to show that that a T-Rex tooth could drive through it, and that it somewhat approximated dinosaur bones. So you can't have like a chicken bone. That would have been, not a good example. So a cow is perfectly fine. And on the field, when we find dinosaurs, we find ribs, vertebrae, skull bones, disarticulated. This is Triceratops, and they're all roughly, in terms of thickness, that they're pretty comparable, and so comparable to a cow bone. The density might have been a bit different, but I think that would have a negligible effect on the end result of driving a tooth model through a cow bone. So the bottom line is I don't have an issue with it knowing the material properties of bone itself. The model is almost irrelevant as long as it's a large bone that a tooth can actually penetrate into. And as I mentioned, the estimates of bite force range from, having a car dropped on you up to a blue whale. Either way, that tooth is going through that bone, no matter what animal it's from. So I didn't think it was problematic. I think it was just very effective to show the power behind that bite and what these animals could really do and the sort of damage that they could do.
Makes sense to me.
Yeah, I was saying, makes the same here. Makes sense to me. I personally tend to lean, I would say, probably somewhere in between. It's like on one hand, perhaps upon hearing, elaborated analysis on what is a bone really, when you understand that might be perhaps even better starting point than actually thinking about the size of the bone itself. And of course, if it's within a certain margin. But I also agree with John's point that he brought up about what could have been maybe the more common prey item source, because T.rex, contrary to what some people out there might perhaps fantasize about, it was not. It was still an animal. It wasn't a pit fighter of any kind. It wasn't purposefully seeking out the biggest and the baddest animals of different species, be it their prey potential items and stuff, so that it could prove a point. So I don't think that was really the whole issue. I think that's the whole issue was not to starve. And what better way to get your meal from than, of course, if you can bite down on an animal that is smaller, potentially maybe a sick animal, possibly with a broken horn if that were the case. So it means not all defenses of that Triceratops could be utilized. If it's an Edmontosaurus, then of course smaller one to easily overpower it comparatively, because an adult Edmontosaurus probably would have been a pretty nasty struggler as it was, even though it didn't have any particular prominent weapons at the disposal, like Ankylosaurus or Trike and Torosaurus as well did. Even a Pachycephalosaurus could probably be a pretty nasty one if it ended up potentially landing that thick-skulled whack, somewhere in like a dentary or something like that. That could be pretty bad, I would say. Like a smaller one, you would think it's something easy to take down, but if you miss your bite and you get rammed with that thing in your face, you'd probably be thinking, okay, fine, I'll leave. So it's, I'm not saying it happens all the time. I'm just saying that it's a very, very interesting thing how sometimes the power of animals is actually very frequently underrated and underestimated in that sort of context. So what are your thoughts about the potential size prey items and the range of, obviously, as far as we already established it a long time ago in our programs, that T.rex would eat whatever is available. So in your opinion, though, what would we quantify as generally available for an average adult Tyrannosaurus Rex?
Yeah, so people actually do model this sort of thing, and the general approach is to assume that adult Tyrannosaurids were eating size match prey. So that, a 40-foot T.rex would be killing, 40-foot ducks and 30-foot trikes, that sort of thing. This is a bit of a tangent. I'll keep it quick. I can't remember if I actually meant we discussed it last day, but T-Rex is a giant Asian Tyrannosaurian that didn't evolve in North America. It crossed into Beringia, and the ancestral stock of the Zhucheng Batar Rex lineage, the ancestral fauna included sauropods and giant duckbills. And so I think that's what these really overpowered Tyrannosaurians were killing on a routine basis. So I think these were capable of hunting and killing sauropods, and I think that's why they're so massive, why the teeth are so thick. They're very different from the Laramidian Tyrannosaurians. They weren't killing sauropods, they were killing big ducks and smaller ceratopsians. We don't see anything like T-Rex or Zhucheng for that matter in North America. It's just this Splendosaurus is as good as it gets. So I think that stock of Tyrannosaurians was doing things that no North American Tyrannosaur ever did. And it's kind of coincidental that when T-Rex entered North America, the Tyrannosaurus came up from the south as well. And they actually their ranges did overlap. And so I'm sure the first Alamosaurus would have been a welcome sight to a T-Rex. It would have automatically known how to kill an animal like that. But anyway, that's a tangent. Big Tyrannosaurs would be eating big prey, just like big crocs eat big prey.
Right. So basically, they would obviously, maybe to better clarify what I wanted to ask there, was they would be more than capable to still take down prey of an equivalent size. That probably would have been my main question. Rather than whether they prefer or not is a different story, but whether they were capable of doing it on a regular basis rather than obviously in exceptional circumstances is what I was meaning to ask specifically.
Yeah, I think these were habitual sauropod killers.
So in other words, to those of you guys who might be watching, don't get too salty, but who knows, maybe T-Rex was actually better at killing sauropods than Giganotosaurus. Oopsie. So, but that's what they were.
Again, everything else would have been on the menu as well. And we know that sauropods were outnumbered in Asia by duckbills. But I do think sauropods were on the menu.
And we also
just given how different the Zhucheng Rex lineage is from others.
The other interesting thing about the Asian lineage that you have brought up that worth bringing up, in my opinion, is the amount of armored animals that lived in Asia, which were not necessarily all anagenetic, like we see mostly in North American megafauna when it comes to late Cretaceous. But a lot of them were contemporaries of one another too. So you've had, for example, at least during the time when, by the way, this is another opportunity, guys, troll, caps lock, everyone, Tarbosaurus, but are basically to hunt these different ankylosaur dinosaurs as well, because they had things like Tarchia. In fact, we actually even know as of recently that there were at least 2 species of Tarchia alive, contemporary with within the Nemegt formation, and they were not anagenetically related from what we know, at least so far, which is what makes Mongolian and Asian armored dinosaurs very interesting in that sense, that a lot of them coexisted as contemporaries in that environment and may have had slightly different niche partitioning from each other, but potential prey items too, perhaps, for a powerful jaws.
Yeah. There's a bit of work done on coevolution of Ankylosaurus and Tyrannosaurs. I haven't read that literature. I know it's out there, but yeah, a few Tyrannosaurs would have been a very specific problem for animals like that to deal with. And so natural selection would have to get its act together really quickly to cope with Tyrannosaurs. And maybe that's what we're seeing there with these really well-armored Ankylosaurians, as you mentioned. Because I think, I can't remember if it's Cycania even has belly armor. So, they have plenty of problems in Mongolia. There's the Tyrannosaurs and the big Dromaeosaurids as well, like the Kilobatar. So it was just a nightmare for them.
Yes, a kilobatar was probably a nasty little pest for Tyrannosaurus, if I'm correct. Though that those were the contemporary species to each other, and because those things were also not only because they're big dromaeosaurids, they were also very agile. Then that kind of doesn't help if you are relatively sluggish. I would say, maybe putting it a bit exaggeratively, but in comparison to something like an agile theropod that could literally keep annoying you until you get really tired, that would be probably a nasty business to deal with. But lucky for Ankylosaurus, when we see the emergence of T.rex, instead of drinking copium with tears, what they were doing is they decided to up the game, and we ended up with an absolutely crazy tank of an Ankylosaurus, which, according to at least Victoria Arbor's recent work on Ankylosaurus that I think was done in 2018, it could grow, according to their apparently conservative estimates, which is quite mind-boggling, 8 meters long, which is just huge for any ankylosaur altogether. They just didn't get that big in Asia, as far as like 6 meters was the tops, basically. And even that is maybe me exaggerating a little bit. But Ankylosaurus going like that, yes. I mean, I've seen the skulls as well. They're pretty massive too. So
they're monsters.
Yes. I mean, that's how far you probably would go if you wanted something as nasty as a T-rex to just leave you the heck alone to eat and do your own thing and mind your own business, I guess. So it would have been really nice, of course, if then this is the reason. I mean, obviously we're doing a lot of tangents, but I'm gonna try to bring it back to the main focal point of the documentary here, is that the reason I think where we can all agree here, both the viewers and us participants here in the show, it would have been better. I mean, for me personally as a viewer, would have been nicer if the documentary explored a lot more when it came to the hunting. If they were to bring you the real T-rex, it would have probably been very nice to show what it would have done in its time when it was living, right, as an adult animal. And why not to basically explore its prey items potentially and how it would have handled it, in its environment, and what sort of things were on the menu, for example. And at that point, when the documentary was made, we already had a lot of information on a lot of these animals, like Triceratops, like Edmontosaurus, many other animals, in fact, as well. And we do know that this ecosystem consists of quite a lot of different armored animals. And if you go from a smaller T-rex, like, size Jane, and maybe even smaller than that, you're looking at potentially turtles in environment, because there were quite a lot of turtles in that environment as well. And then you're looking also at some of these relatively small crocodilians, because obviously these Dinosaurus sized were already extinct in that ecosystem by that point. So, you also have different Ankylosaurs and Nodosaurs in Hell Creek. Well, specifically Ankylosaurus and Denversaurus, Schwesmani, and those ones are pretty big and hulky, and they have a lot of nasty armor and tail clubs and all these things that, if a Tyrannosaur was desperately hungry, would have had to deal with it. So I would have liked to see how they would have shown or addressed how Tyrannosaurus would have dealt with these issues. I wanted to see more about how it would have dealt with certain situations in its life if we were to be convinced that it was a real thing. This is what I would have wanted to see, rather than just say, let's model it, let's give it a bunch of sounds on a replay, and let's do this and with this color. And of course, not to mention the influffening bias, when he just decided that he's going to give it a mane, which he actually called it a mane, because he simply said, I like it. That's the reason. That was the reason. I just like it.
Yeah, that's when, the credibility really suffered. I think I agree that, probably everything was on the menu, for any predatory animal in that environment, anything, within the realm of possibility. So, I don't have a problem with T-rex eating turtles or crocs or anything like that. I do think this isn't, I'm not being facetious, but my impression is that they probably couldn't show all of that, possibly just by budget limitations. The sort of the culmination was to, the big reveal was the model. And, that did take probably a significant budget, a lot of time and effort went into it, even though we might not agree with the end result. But it might just be the intrinsic financial limits of the program itself. Who knows? Maybe they wanted to, go further and show more of the fauna, but there are these, real limits on a production of this sort.
Well, Dr. Carr, you do not say, because I do have not necessarily, I don't think I would have to sell you that bridge, because I think you would quite happily buy it, and I will explain why. You see, they are using quite a lot of copyrighted footage from other programs and of movies, and a lot of copyrighted music material. So what do you know? These things, according to at least Joshua Volsey, who, by the way, I want to give credit to for pointing this particular point out. I hope that there was an opportunity to bring it up, and I think he will be happy when he watches this show to find out that it came in handy. But he is somebody who is a very good insider in the sense of the production side of things when it comes to Hollywood projects. So he knows exactly how much these kind of things would cost to make. And that was one of the main things that he was actually pointing out, of how much budget would have gone into all of these different stock footage materials of these different parts that were included, including the music and everything, where he said, guys, you could have just invested this into a better CG model. You could have just brought us a better looking T-Rex instead of just using this recycled stock, recycled footage, which is where you could have just completely neglected it and just given us all the points would have come across if you were just good at making points rather than just trying to, use these different shenanigans which just didn't land and they just costed a crap ton of money. So yes, Dr. Carr, I can probably agree with you. I give you 90% chance that that was probably a financial issue with that in mind. Maybe it was for different reasons than what we both thought, but I think financial issue could have been an issue, sure. So as to quote Ian Malcolm and give that impression of the scene, which I'm probably very terrible at, when he goes, there it is. So, John, do you have anything to add to anything that we have just covered in this exchange in the last few minutes?
Well, I personally, I kept quiet for most of it because I just find it fascinating just talking about this and talking about, how did Tyrannosaurus Rex really become what it is. And I think the discussion about how Tyrannosaurus Rex came from what were essentially sauropod killers in a way, I think that's very fascinating. I think it's something that really should be explored more. And actually, I'm familiar mostly with the arms race between ceratopsians and tyrannosaurs, but I think it's easy for me to forget that, they lived alongside ankylosaurs for a huge chunk of their history. And I think, it could have been a double arms race where it's like you've got these two groups of animals that are trying to survive against this one very successful and one very efficient group of carnivores. And I think that's something worth exploring more. And I think that may be the biggest problem I have with the real T-Rex. And obviously I know production costs is a viable concern, but I just think there's so much nuance. There's so many things that they could have talked about with Tyrannosaurus Rex, and obviously not to say that, well, they should have just made it into this movie monster kind of creature, but really explore what made Tyrannosaurus Rex unique amongst dinosaurs, because it is a pretty unique animal for it being like one of, if not the most famous dinosaur of all time. It is remarkably unique in comparison to quite a lot of dinosaurs. And I think there could have been so much they could have explored, but the stuff that they talk about is either very simplified to the point that, like, for example, with the whole, when you mentioned, are T-Rex teeth really sharp? And, I'll concede, I concede that I am a bit incorrect with what I said compared to what Dr. Carr said. But I do think that even if the show were more accurate on that point, they needed to do that. They needed to do that extra legwork to really compare T-Rex teeth to other animals and go, well, this is why we say this, and this is why T-Rex teeth were built the way they were. There's a lot of things they just sort of simplify and boil down to the bare bones, and when they really could have gone a bit further with it. And then there are things that they just kind of just talk about without really understanding what really needs to be there to explore. Like, for example, fuzz and all that. And for me, that's the biggest thing. There's a lot more to talk about T-Rex than I think a lot of people think about, despite the fact it is so famous. And this could have been a really good opportunity to talk about that, and they didn't for one reason or another. So
I think that's a really good point. And that, I think, brings us to a more fundamental issue. And that is, it makes sense to have, well, it's important who's in the driver's seat. So you wouldn't have Cosmos without Carl Sagan. You know, you have an actual scientist in a driver's seat on that in terms of narrative and content. You have the follow-up with Neil deGrasse Tyson, who's qualified to be in the driver's seat. You also have a number of documentaries on astronomy and such by Brian Cox, who's qualified to be in a driver's seat. And I think an unfortunate trend in paleontology documentaries is that the scientists aren't in the driver's seat. It's usually, you know, a TV presenter who has little or no background in the topic, and therefore cannot get to, you know, things that are a bit more interesting scientifically, maybe a bit more meaningful in terms of the big evolutionary ecological picture. And I think that is an important sticking point, is that expertise does matter, because it really does bring insight and perspective to a topic instead of, you know, a fairly limited set of topics to discuss. So that's an issue I have with dinosaur documentaries in general. Prehistoric Planet was different. It did have, the main consultant was, you know, is a degree paleontologist, had a good roster of PhDs on it as well. So that brought a bit more depth, made things a bit more different, you know, unusual and that sort of thing. So I think there's value in who's in the driver's seat. I think it makes a real difference. And in this case, you know, like, for example, if there's going to be a documentary on Triceratops, I'd want it to be John Scanella's Triceratops. What's his vision of Triceratops biology and evolution, since he's the world expert on that animal, curator at the Museum of the Rockies? His whole career is based on Triceratops. I would want his vision, and not some presenter who, you know, isn't even a paleontologist.
I wanted to add and maybe expand on this last point, because I am frequently, let's just say, I wouldn't say guilty because I don't feel any remorse for saying that, but I'm frequently accused of, you know, being, what's the best way to, I'll just call myself a pest about the issue, okay? It's when I argue or debate with some people about an issue, and they say, but this scientist, insert the scientist name, said that, and therefore your point is less correct than that. But what I encourage in this conversation is to get away from the appeal to authority of a specific individual and actually try to look at how, you know, don't pay attention to the name attached. My point would be more so than look at how the person who you are citing has done the legwork and achieved the conclusion. Because at the end of the day, if the person is actually able to demonstrate it, this is what makes the work valuable, is the lengths they go through to actually give you this knowledge. It's not necessarily that they said something, because anybody can say something and have a degree attached to it these days. Especially, it's very easy. You know, you can, in some cases, you could probably even buy a degree and you would be called a scientist, but that doesn't mean you actually know something. So, and the best way to understand that, in my opinion, is to actually go to the point of, and this is where I think I'm going to go to the point of where I think the problem was for me in this documentary in general, and in many other projects of similar kind, is the lack of demonstration of how these conclusions are achieved and the excessive cherry picking and tailoring of certain quotes out of slightly maybe out of context in some cases, not always to the extreme, but in some cases when it, when the small grains pile up, they create a mountain, right? So you kind of get this impression that it's almost sometimes tailored to present a certain point of view rather than just giving you an objective factual information of what different people think and how these people arrive to the conclusions. So you yourself as a viewer can then maybe take a closer look and assess, the validity of these conclusions and how good of a quality they are. For example, if somebody is citing evidence for something, then you would want to see how good of the quality of that evidence is, and you want to see how they've tested. For example, how did they test the T-Rex had this bite force? How do they know that it was a scaly animal, not a fuzzy animal? How do we know that it was able to perhaps, I don't know, run at certain speeds and not the other speeds? And how do we measure, what do we take into account, and how do we take all these different variables together and put them together? So, and I think the reason why I think, many people trust you, Dr. Thomas, is because you are able to demonstrate how you reach these conclusions. I'm pretty sure that if you did not do that, and you were not taken to task, to do that, and I'm pretty sure a lot of people probably challenge you on these different positions, and you're always forced into a situation where, well, maybe not necessarily forced, you seem to be very welcome into it, but well, people disagree with you and they try to ask you difficult questions, but somehow you seem fine, you seem to be alive and well after all of that. So
Yeah.
there must be a way around that. So before, of course, I know that you probably have to go soon, and in fact, the program has gone on long. We have covered, by the way, all the major points already. So this is just general stuff
Good.
anyway. It's just overall to add whatever we can to further maybe propose what could be improved if they were to redo this program. But what are your thoughts about perhaps this last point about the quality of how people reach conclusions and the program's lack of demonstration of how these conclusions are actually achieved, so that when they try to be sciencey, if you will, if I dare use that word, it's like they try to start and they spoil you on some little bits and pieces, but then they don't fully reveal how they do it, and they just quickly move on to the next point, and you're left there thinking, but wait, how did you do that part? How did you do this part? So what are your thoughts about that before we close off?
Yeah, I think in terms of documentaries like The Real T.rex, I think it's important to show in a brisk and clear fashion what's gone into, say the model. Like, say I was consultant on it, or was, Carr's T.rex, I would go through, briskly and clearly each major point, so that the public can understand that none of it's made up, and all of it is grounded in reality to some degree or another. And we pointed out earlier that there's some wiggle room there based on just the facts of extinction and the modern fauna. But I think that, taking different, like starting with appearance, like how do we know what they look like? Where's the range of accuracy there, and then maybe take on, kinematics, just walking, that's constrained by joints. So people would learn something about joints, and then speed, that brings in muscles and physics, and then behavior, whether it's reproductive or hunting, that pulls in the EPV again. So there's real opportunity to show people how the science really works in building up our picture of these animals. And that hasn't been done yet. And out of all due respect to Chris Packham's efforts, I don't think it really does that job, because I have a version of this in my own head of how I do it, and it would be pretty step by step and building up from the skeleton outward, and being very clear with people how we actually think about these problems and how we really approach them. It's not a black box. There's no mystery involved. There's no make-believe at work either. We try to really keep that to a minimum. So I think so what I would prefer to see is, my imaginary John Scanella's Triceratops. I'd want to see a documentary of going from skeleton to the flesh, changes during growth, kinematics, speed, eating, digestion, that kind of thing, just walking through the biology of the animal based on actual science that people have done. And I think a documentary like that would rely heavily on the work by Larry Whitmer and Casey Holliday on amniote musculature, which has pretty important implications for the appearance of dinosaurs and other extinct animals. So I just don't think the job has really been done where the scientist is in the driver's seat. And I want to see that because I think that the public would benefit most from an insider's view.
So how about we do a program with Dr. Carr's and maybe Dr. Curie's and Dr. Holtz's T.rexes and just try to eventually do like a scoring at the end, see like, well, guys, we've got a race going, just make it a little bit interesting and spicy towards the end when we get to the conclusion. And then, of course, but joking aside, though, I would be, because there are multiple people in your field, and the reason I named them in particular is because all the other two have named, Philip and Thomas, your namesake as well. I have had a chance to also ask them these kind of different questions, and it's very interesting that you do share some views, but they also have different views on some things, and they're also in different areas. So that's one of the reasons I wanted to see how that would all come together when you make that T-Rex from these different perspectives.
Yeah, I think that would be a very illuminating exercise. I would want to see something like that because we don't all think the same way, and we're not all working from the exact same approach. I think that would be quite revealing about the way we think. And it would also show the public that, scientists can approach the same problem from slightly different ways. And, those might be mutually reinforcing, or they might expose questions that still persist, or it might show that one line of thinking might be completely wrong. So I think, like a comparative, 3 versions of T-Rex would be an interesting approach, or any other dinosaur for that matter.
Of course, and there's probably plenty of people out there who would have been. Well, I mean, I'm glad that you are at least interested, so we just have the other 2 to ask now. It's 2 more to go. If that's a game, then here we go, Indiegogo, I guess, and start raising funds for that. But anyways, thank you. Yeah, go ahead. Sorry, Thomas.
Oh, just the last thing is, in the Jane monograph, you will see exactly what I think T-Rex looked like, at least the young ones. And you'll see exactly what behaviors I think they were capable of. So the monograph will take us some distance toward answering, those questions.
It might give you a potentially slightly unfair head start and advantage, perhaps, in some areas, because I don't think anyone has quite invested into producing this kind of nuanced, in-depth look into not only just T-Rex, but into a specific age group, a sample of T-Rexes, which is the younger age, which will be quite interesting to see. So in any case, I think that we are reaching generally our conclusion. And I wanted to thank my co-host, John, for helping me out and for just providing a third, opinion and view. So it was a very nice, I think, triple exchange of opinions. And of course, most of all, I wanted to thank Dr. Thomas Carr for not only coming to the program, but for also reaching out and being particularly showing a good interest and enthusiasm for coming back to the channel and to the show. I'm hoping that we will see you here again. Maybe we might do some more interesting mental exercises, like get some of my friends over here as well and just pepper you with questions and try to get you to shoot away with all these brilliant answers, just so that we can also see how much you like to, you know, engage into the process when somebody scrutinizes your views as well. And I'm saying scrutinize as somebody who mostly agrees with you, by the way. So I think that makes it even more interesting, because you know the views and the points so well that you are starting to think, okay, how can we actually try to see if we can disprove it and catch, you know, the other side on something. So if you are interested in something like that in the future, perhaps let me know as well. We can definitely work something out.
And thank you so much for having me back.
No worries at all, always welcome. And we definitely have many topics to explore. So anybody in the comments, please, after you've done obviously copying and pasting Gorgosaurus caps lock and Tarbosaurus caps lock, you will also hopefully leave your feedback. Let us know what did you think. What did you think about the points that we've brought up? Who do you agree with most or disagree with most on what? What other things you would like to see from Dr. Tomas or from myself and John in the future, aside from what is already planned, and all of that lovely jubbly jazz. So thank you, everybody, and I will end the show now, and we'll see you guys later. Take care, and bye-bye.
Ciao.